evening, everybody. Sun and Moon again on Friday, the 25th of August, 2017. Welcome, everybody in the chat room and everybody who's watching this hangout tonight with us. We have Patricia, UK, Series Holland on Friday. Oh, no, I do that every time. How embarrassing. Forgot to turn myself off. Right, I'm off now. August 2017. Excuse me, sorry. Anyway, Patricia, UK, Series from Holland, and Chris from Canada so far. And we also have a few guests waiting to come on shortly. But we thought, first of all, as we would still play a couple of videos of the eclipse, and Series has got one ready. So we'll just watch this because it's quite a different version of the eclipse. Series is just, that's it, Series is presenting. Just wondered what everybody in the chat room thought of this. You sent me this today.
It's a little bit slow.
Are you playing, Series?
It's a little bit slow.
Yeah, it's got, you may as well talk, you may as well play the volume, Series, so they can hear what the guy says.
It doesn't change sides ever, right? So there it is right there again. I'm going to slow it down for you. Anyways, here is where the moon comes from the sun. Now, I'm going to, right here, it does a little glitch. So take a look. It kind of gets a little bit smaller and then a little bit bigger, and it kind of messes with the size a little bit. So remember, this is supposed to be the solid moon that doesn't change size ever, right? So there it is right there again. I'm going to slow it down for you guys. Take a look. It's getting bigger. It's like pulsing, smaller, pulsing. It's like up and down, up and down. You see it? It's like a little heartbeat almost. So anyways, I thought I would just throw that out there because I was watching this footage over and over and over, and I caught that. I don't know if that is a focus issue as well with the camera, but to me, it doesn't look like it. And then when the moon goes away from the sun, as we're going to see here, it doesn't look like a big ball moving over to the left. It looks like it's just sort of vanishing, right? And people say, oh, well, that's because the sun is hitting the back of the moon. We can't see the front, so it's blackened out. But that doesn't explain how we're going to see it completely vanish. Now, here it is zoomed in slow motion. So it's starting to vanish from the top right corner, and it just disappears. It doesn't seem to move away from the sun like we're being told. It's almost like a black hole was created in the middle of the sun, and then it went away. Look at it. That's not the moon moving away. You can still see the round part of the eye. We should see that kind of travel to the left a little bit. And I know I'm going to have hundreds of people come in this one as well and try to tell me all this scientific explanation. All you need to do is look at the footage. It's right here in front of your eyes. Just watch it over again. I've watched this over 10, 20 times. It doesn't make any sense. So I'm going to leave you guys with a little shot, the exact same shot. This was a camera taken right beside the one that we just saw. This is a different camera. I'm going to leave in the description the name of the cameras, the source where I got these videos from. Thank you very much for showing me this. Make sure you guys go check out his channel, give him some support, give him some likes on that video. And if you want to see the full version, you can also check his channel and watch it there. Thank you for watching. Please fill these comments with what you think you are seeing. You heard what I think it is. Now I want to hear from you guys. Thank you for watching.
If you ask me, he's still suspicious.
What do you all think of that?
Looked like it was blinking to me.
I have to say, when I have actually pointed my phone camera at the moon, I've seen that pulsating thing, and Series probably say it's the camera, on the phone, but I've seen that pulsating like that. But what do you think about that, Patricia?
Looks like, I don't know, I've never seen it like that before, but it just reminded me of like a reptile blinking. I know they have two sides, don't they? Like we blink down, they blink across. Just, I don't know, just looked like that to me, but fascinating. Like I said, the first time I've seen it like that.
Chris, what do you reckon of that then?
Well, I definitely think there's some camera effects going on, right? The camera is trying to decide whether to focus on polarized light or refracted light. It doesn't really know what to do because the person in the video obviously think it's the moon there, but like we've discussed here in the group chats, there's no evidence that it is the moon causing the eclipse. So I would say a little bit of both.
Black hole. I thought you said black hole.
Well, he said it looks like a black hole, but he says it's the moon in one breath and then a black hole in the other. So he's looking for answers. The poster of that video is just looking for input from the public, I guess. So my input would be that there is no moon object, and the camera is deciding what to focus on, and that's why it pulsates, because it doesn't. Cameras aren't very good at capturing polarized light because it's polarized. They depend more on refraction in the sensors to work properly. So that's why moon pictures are so hard to get. Unless you have some good filters and some that type of stuff too, right? Because the moon does polarize light. So but that doesn't mean that the moon is in this image, right? It's just a similar type of light source.
What do you reckon with that object not actually moving off the sun and just sort of going into a black hole and then disappearing on the sun? What do you make of that then?
I don't think there's anything there.
What do you mean?
It's a phase shift of light, and then it's bouncing it off a magnetic field, pretty much, and focusing through.
So that gives you more. That gives you like more evidence of what you're doing then.
Absolutely.
What you're understanding.
Yeah, it's a good video to look at for that type of thing. Yeah. What else is interesting about that video? I noticed to the whereabouts was it? I guess to the left-hand side around 10 o'clock.
Series, play it again.
There is what appears to be a star, which are probably Regulus in that angle, that becomes visible during the eclipse. And it's ironic too, because Cindy Holland actually sent me this video earlier today too. So this is the second time I've seen it today. So it must be circling around a little bit amongst the community. So
another one up.
Fill these comments with what?
This time, Series. Thank you. Series is having problems.
Problem.
You need to put it back, Series. Oh, I see you're playing another one.
No, it's the same one, just the overall view.
Looks a bit like an eye. Hello, Peg Leg. Peg Leg's in the house.
Hello, everyone.
Hello, Craig. How are you?
Not too bad, you guys?
Yeah, we're okay, thank you. We're just
good.
watching a video of the eclipse, if you can see, because there's just this sort of strange thing happening there.
Oh, I can't see nothing. I could just see your thing come up, a picture of you. Oh, yeah.
Yeah, you see it now?
Yeah.
We were playing this till you came on.
Okay.
And we've got a few other guests as well.
Okay. Who's on tonight then?
Well, I've sent the link to Jamie Brown.
He joined.
There he goes, as I speak. And Dave Marsh is coming on as well.
Okie dokie.
Hello, Jamie.
Right.
How are you, Jamie?
Not doing too bad actually. Just looking forward to the meetup tomorrow.
Sunday.
Tomorrow actually, I've got my own meetup
right.
going on, and so.
So where are you going tomorrow then?
Preston.
Right. Okay. One. Jamie, are you going to the Cardiff one on Sunday?
No, I won't be going to that one. It's quite a distance away, really.
He in the chat room probably knows who Jamie Brown is, but here's Jamie Brown. And Jamie, I don't know whether you've met Chris, Jamie. If you've met Craig, and Craig is Peg Leg.
Yeah.
Chris.
Chris, I'm not too sure about.
Yep. Hello, guys. Nice to meet you both.
You alright?
Anyway, if you've been watching our channel lately, Chris has been an absolute asset and been researching with us and doing some amazing work. Craig, do you know Jamie Brown? Craig, do you know Jamie Brown?
Not really. I can't say I do.
So Craig, Jamie,
I think I've only because the first time I came on here, I think Peg Leg was on, but we didn't really talk to each other much.
Yeah, that's when we first started going on live shows, wasn't it?
Yeah, that was a while ago now.
About the end, yeah, probably June.
Yeah.
Well, nice to see you again, Jamie.
So, Craig, what have you been doing then? You've been making a video, haven't you?
Which one was that?
About yourself? You put a new icon up, didn't you?
A new icon. Which one was that? I've done a few.
Prince.
Say again?
A Middle Eastern prince.
Middle Eastern prince?
Yeah, you had a picture sort of very Indian-y like.
Don't think so.
Well, maybe it wasn't you then.
No, I don't think it was me.
Do you want to explain, because obviously we know you, but do you want to explain a little bit to the chat room about a couple of your videos? I'll put Craig's link on the description at the end of the hangout.
Yeah, basically a flat earther, a believer in God, and basically that's what I really talk about, is those two topics. I have talked about being a free man and, third party debt, should I say, and stuff like that, basically. But yeah, that's about it, really.
Anybody who doesn't know who Jamie Brown is, what do you generally do, Jamie?
Generally hangouts. I've not been as busy doing the hangouts lately, but yeah, I try to kind of keep it open to different discussions and things, not just kind of pinned to flat Earth, because to me that could be the psyop, they keep us all sectioned in one group and not kind of able to reach out to more people, really.
Okay. And yeah, Craig, are you going to any meetups or anything?
Not at the moment.
Well, we're waiting for Monday. Yeah, I suppose going to Cardiff's a bit far for you, isn't it, really?
Yeah.
So what's your vision of the eclipses then?
You talking to me?
Yeah, Jamie or Craig. What's your feeling about what you saw with the eclipse?
I don't know. I didn't even know there was one in England. I just knew there was one in America. But I also hear there was one somewhere else as well. And
it went down to Portugal.
Yeah, that's it, Portugal. That shocked me because I was just thinking it was America. Then I find out it was England, and then another one, Portugal. was like, what is going on? But yeah, what do I think of it? I don't know. I do think there's a sign there for those three countries, really, for us seeing it there. Whether it's like a sign from the Bible or anything like that, I don't think so. I just think it was just a natural thing to happen.
Yeah, just we don't understand it. I mean, what's your version of it, Jamie, before I say, obviously, what Sun and Moons is?
Obviously, like, it doesn't really, like, prove the shape of the Earth, but, I mean, it could, like, show some kind of flaws in the model. I don't know, but because there's been a lot of discussion about, like, how the shadow being 70 miles and it's been a lot bigger and all these things. I mean, it's kind of more like problems for the helio model over the globe model. I don't know. It's not really something I'm really too invested in, to be honest, because I feel like it's kind of distracting from the obviously being no curve, and so it's like we're playing by their rules, and they'll probably just come out with another excuse to patch it up. That's how I feel. It's whatever people come up with, then they'll just come up with something else that would be able to back up their model.
Well, Sun and Moon, through Chris's work, say the moon wasn't there. That's what we put out, is the moon isn't there, because it's not. But I mean, it's obviously a natural thing, but I just find it, like you say, it was in Portugal, in England, it was in America, it also was in Mexico. And in Mexico, it was the other way round. It was coming in from the left to the right, whereas everybody else was getting it right to left. So you think, what? Just the whole thing is completely strange.
I've seen all these like comments on social media saying that it proves the globe, and how can flat earthers explain this? I was like, I didn't really understand what kind of how it would prove the globe, because I just saw it as something was coming in front of a disc and blocking it. How can that prove that we're on a globe?
Again, I think they were putting chemtrails up. It was cloudy. I mean, England was so cloudy, most people here didn't get much of it. Stan Smith did. A lot of people, if it had been clear, there'd been, imagine how many videos. But it's a
I saw these like pictures, and people thought that there was like art, like the chemtrails like going through the eclipse or something, and they thought it was art. Like, people are just so brainwashed. I mean, not that they thought it was art, but they probably just thought it was look cool or something. They don't obviously realize the agendas at play and things that with this chemtrailing thing. I think there's probably multiple purposes of it, really. But that's another topic in itself, really.
Yes, it is. Chris thinks that they're using that to keep us warm. Basically, they put that up so it keeps us warmer. And in a sense, I think most people might realise this, because very nice weather here, because we haven't. But when we did, it's a bit like they're saying the temperatures are in the 20s, but it feels like it's in the 30s or something, or the 40s. It's just so warm. That's not how saying.
So you think they're like lying about the temperatures and things, like the average temperatures?
Yes, I have to ask Chris to explain that. Chris, explain why you think that they're using the chemtrails, if you don't mind.
Well, when I researched, went back in history, they've been spraying, NASA in particular, but NASA and lots of agencies have been spraying barium chemical, at high altitudes, and they're still currently doing it. Barium releases, some of them by the tons, or tons and tons of material just being sprayed up there. And barium, when I looked it up and looked at the chemical properties of it, it's a man-made element, and it's also highly reactive to microwave energies and magnetic fields, and it's high altitude reactive, and they're still currently doing it. Barium releases some of them by the tons, or I'm feeding back there, Karen. Tons and tons of material is being sprayed up there. And barium, when I looked it up and looked at the chemical properties of it, it's a man-made. Karen, somebody.
Yeah, the mute doesn't work.
There you go. If you just Google, you can search for barium, the chemical composition of barium, and even just do barium /NASA or whatever. You'll find all kinds of reports and back there.
It's not me, it's Series. Right, I've turned Series down for a minute. Who's that? It's Jamie then.
No, it's you.
It's Jamie. Jamie, you've got to mute Jamie.
No, it is you. You're just very late.
What's going on? I'm just sorting it out. Right, it's Jamie. He's muted now. Sorry about that. Woo!
Yeah, so long story short is barium is basically a microwave reactive chemical they're spraying up in the air, and it would have multiple uses. Originally, it was a pesticide. It was developed as a pesticide, so obviously it's not good for the environment should it decide to start coming down, which it probably does. But it's also good for studying the microwave field and the magnetic field, and it's good for carrying scalar waves. So you can use it in communications to enhance microwave communications and radar systems, radar communications. So it's a multifaceted type of thing. So, and definitely real. Very strange. That's what they're using it for.
Sorry, actually, it was me. For some reason, my live feed went back on. It was me. I'm really sorry, everybody. It was me. I never pressed it back on. It just went back on as I turned the page. I wonder what was going on. But it might be it's because something else is happening, and it's to do with the eclipse, yeah?
Well, during the eclipse, they did do a lot of spraying, and I did get reports from people all over the U.S. It was just polluted with spray. They started spraying early, and friends were sending me pictures of what the heck, because the skies were blue this morning. Now you see all these planes, and they were spraying, and the forecast was calling for good weather, and it just went like a white haze. But if you kind of consider that as the eclipse occurs and its path of totality, traverses the continent of the United States, then if you had all this material sprayed up in the air, then you would be able to, with radar stations, image the column of the magnetic interference in a three-dimensional sense. You just triangulate, and you can actually see the effect of the magnetic field being altered by the path of totality. And we know that from the Alias effect and some studies of other scientists, that during an eclipse, if you're swinging a pendulum or a magnet, that type of thing, then the path of that magnet can be altered as it passes across. So they're just trying to figure out magnetically what the cause and what actually it is, right? They obviously have no idea. They know it's not the moon, and clearly in pictures and video, and the moon's never seen during the eclipse, and it's obviously a magnetic interaction of some type. So I suspect they're quite baffled, and they're taking advantage of it while also pushing the agenda of the chemtrails straight ahead, right? So it's all in one, bang for the buck, right?
They wanted to make it as difficult as possible for everybody to see the eclipse, didn't they? I mean, they couldn't do it everywhere, fair enough, but they've made it quite impossible for us to see it. Yeah. And that was on purpose, wasn't it? Because it's very strange that we get to see this eclipse when they said they only concentrated on America. They didn't say anywhere else was getting it, did they?
Well, absolutely. I think they were trying to hide it, make it as hard as possible for people with the higher end gear. Now we all get P900s, or not all of us, but many of us have P900s, and a lot of high end telescopes and gear. So this one is, an eclipse like this hasn't occurred in 111 years. So I suspect they're just trying to blank it out to keep people from seeing it, and, keep people dumbed down to the truth. And
I mean, it is a bit crazy that we didn't know it was happening here. Yeah. It was sort of like maybe you could see a bit of it, but afterwards it went down. It was as far down as Portugal. Yeah. Portugal was going to get it, did they? Did you ever hear anybody say Portugal? They just talked about America.
Yeah, well, most of the focus was on the States, but there was a lot of anomalies that I saw that people captured, even with all the chemtrail spraying. I mean, people were dedicated, and they caught what they could, the best that they could, and they still caught enough good data. And high altitude balloon with 360 cameras, and the top end cameras and telescopes. I got some great photos from friends, that use really good gear with filters and the solar filters and everything on it. So I got enough information here now to sift through. Last me a month, so it's kind of why I'm reserving my final opinion until I got a chance to look at everything, in an unbiased way, come up with some conclusions that make sense, that I can back up any claims that I intend on making. So make sure I can back it up and it's irrefutable as far as the analysis of the photographic record that everybody captured as a group. I mean, people put a lot of effort into it.
I know you may not have prepared for this, because obviously we were talking before the hangout, but I just wondered if you could show Jamie and Craig a couple of those pictures, basically with the no moon there, and you've got one that's got they're coloured pictures. Could you show any of those, Chris?
Yeah, I could show you some of those. Yeah. Let's see here. Stop. Which one was it here? I thought I had a good example of the fakery too here. What to watch out for if you're trying to do analysis. These guys are. I'm moving down.
That picture that just flashed up was a really good one.
Yeah, I'm trying to move it.
It just came on for a second.
Trying to move it down into the string here. For some reason I can't see the thumbnails, but there. Okay, so there's. So what I'm doing is I'm looking at pictures online, stuff that people are, posting, trying to make claims that, look, I caught the moon during the eclipse, etc. Right. So this is an original photo. I verified the source, received it, and then somehow this picture ends up being posted later on. Someone pulled down this picture and superimposed a moon in the image, right? So you can see that.
So you're saying there was no moon?
Yeah, he's going to show you, Craig. He's going to show you in a minute.
Right. So this is the eclipse as it was caught originally. Someone puts this moon image in here, and then I analyzed it using the luminance gradient, and you can see that what they've done is now you've got 3 different layers here, right? So they've superimposed it, and so it's a clear double image, right? So they're faking it, right? There's nothing there. And then what I did was some original photos that I got directly from the guys that took the pictures themselves. Here's the original raw. It's a raw photo taken with I think it was a P9, or this one might have been a Nikon, like a high-end Nikon. And so I took the photo, did the same basic idea, and did the analysis on it to see what actually, you can see that the rays of light, it's kind of like in that video, it kind of closed up on it. There's no actual body that the light is actually going around. It's just being kind of bent into the magnetic field, right? And so all the photos end up the same way there at all, no matter how you analyze it, except for the ones that are faked, right? So that's what's going on.
Yes, so there's nothing there. Did you see that, Jamie and Craig? Nothing there.
Yeah. It's kind of strange, though, to be honest. I mean, how do you fake a moon? Really? But I know it probably is possible. I mean, you know, look how we've been lied to about the flat earth and stuff. So, yeah, I get it. But, I mean, I was watching it live on YouTube, you know, in America, and it looked like it was just a blank disc. A black disc,
Yep.
You know, like those in the cartoons, you get like a black disc and you throw it on the floor, you could jump through it, sort of like that. Do you know what I mean?
That's exactly what it was. Chris, could you just explain what you think that is, by the way?
Let's go try and find a picture here. Let's see. What is it?
Charles, it's so funny. While you're doing that, I wondered what you meant. I didn't catch the words properly, but I saw something. So I asked him, what did he mean? He said, I'm waiting for you to go, So there's a for Charles in the chat room. Anyway, carry on, Chris.
So I'll just kind of show you what I think is actually. Let me jump out of that and reshare the screen here. I'm going to pull that one out so I don't share the Hangout. So basically what I think in the end, what's happening is basically this. Now look at that right there.
That's the effect.
That's the effect, yeah. So what happens is when you hold a magnetic, like a strong magnetic field,
I've done
light,
that before.
Right? And so you just end up seeing a black hole in the center, and the light's still trying to come down this tunnel of magnetized particles and field and everything else. So it's still trying to come down through it, and you end up with the eclipse being just a perfect representation of itself, and the boundary is reflecting off the inner tube, so to speak. So you will see some of the image of the corona, whatever's behind it, but basically it's the sun canceling itself. It just reaches a node in the magnetic field where we're in like a toroidal field, and when it crosses that meridian point of the tunnel perfectly and kind of gets stuck in that for a little bit, then you just see a black hole in the center. It's just canceling its own light, right? So there doesn't have to be an object there to cause an eclipse at all, technically. Yep.
Can I ask, do you think they've been doing this all the time with the sun and the moon with an eclipse?
What do you mean by they've been doing it? What do you mean hiding what it is, or actually?
You know how you're saying, like, you know how they sort of done it this time around, like it's not even the moon per se, but it's something else maybe, I don't know. But do you think from like the beginning of time it's been happening, or they've just changed it and the eclipses don't happen as much as they used to, sort of thing?
No, I think it's always been this way. Yeah, no, I think it's always been this way, and I think that's where the legends of Rahu and Ketu, and because people that watch the eclipses didn't see the moon, so in some cultures they don't even think it's the moon at all. It's Rahu eating the sun, because it's a magnetic nodal point where the sun passes through, and when it passes through it cancels itself. So you wouldn't see any moon at all, and the distance of that focal point and how the spread of the magnetic field is large enough, and coincidentally enough that it happens to be where the moon is also in that field, and at that time you just can't see the moon either. But it's not the moon actually in front of the sun, it's just in proximity to it during a new moon phase, right? So they're kind of lined up in a magnetic barrel, so to speak. You got the moon that's a dielectric, a sun that's a positive, and then there's something in between them that's the neutral charge, and it's trying to split the field and cross the wave, right? So both objects kind of disappear at the same time, and the other one we just see as a black hole. Right, so it's fascinating. I think it's fascinating from an electrical standpoint.
Yeah,
I think it's always been that way.
Now I get it. Now I understand what you've been saying.
Right. So that's why NASA's been trying to spray, obviously in advance of this, to study the effect on the ground during the eclipse. Like if you were standing outside, like I was during the eclipse, I was in Canada, so I didn't get totality. But even here, being 600 miles north of where it happened, I could still feel the temperature change and the hair on your arm stand up, and people get that spooky feeling during the eclipse. And I think that's because there's an interaction between the dielectric neutral of the Earth's surface and that eclipse happening above, where you're now standing in a negative column of cold, negative ions, and you feel it because it's cold, right? It's actually a change in positive ion exchange, and you'll feel it as a temperature shift. The wind picked up for a bit, and then the wind died down. After the eclipse was over, it was hot, right? And it completely changed everything, for that period. So it's not so much a shadow being cast. It's not a shadow at all, actually, being cast over an object. It's just a complete cancellation of light. and photons. It just changes everything. So I'm sure that's what they were trying to figure out and get an image of.
We're trying to stop us. Can I just, Dave Marsh has joined us. Hello, Dave.
Hello, can you hear me okay?
We can. On the panel today, we have Jamie Brown and we have Pegleg, which is Craig Scarrett, and obviously the series, me, Patricia.
Hello all.
And
Hello.
Dave Marsh, if you haven't met him already.
Yes, I've met a few of these. I think we met Jamie at that meeting a few weeks back.
Yeah.
Oh, yeah,
Obviously,
cool.
no, I don't know about that, though.
Can I just say one thing, Jamie? Loads of people came up and said hello to me at Leamington, and I was a bit sort of aghast back at how many people said hello to me. And then I really thought you'd know who I was, and I went, Jamie! And on my pictures, you turn around and you look at me as if to say, who the hell is that? It was me. It was me. But you didn't want anybody to hug you. Well, that was a huggy day that day.
Yeah, it's just sometimes I'm alright. Just I don't know.
You didn't want any hugs that day, did you? And Jamie's really tall, aren't you, Jamie? How tall are you? 6'3", 6'4", or something?
Yeah, something like that. Yeah. Yeah.
Anyway,
I must have giant's blood in me or something.
Anyway, one thing I just say, thanks very much for showing that, Chris, because we've just suddenly changed the subject there. But what Chris has looked into is absolutely amazing. Really, like, wow, not many people out there will have worked out like Chris.
Yeah, he's done an awesome job on that. Yeah, I'm quite impressed with that, because, like I say, you know what I mean. It sounds more logical, doesn't it? You know what I mean? To me, it does to me anyway. Makes perfect sense.
It does, yeah. And it's just amazing that all that time we would have just said, oh, look, it's the moon eclipsing the sun. And it never was.
Okay.
Why not
Can I just ask a quick question? I think it was sort of late 90s, early 2000s, there was an eclipse. And I was standing on the banks of the River Thames. Obviously, I had the silly thing to put on the eyes so you can't get blinded by the sun or whatever. But I want to ask, did I actually see an eclipse of the moon and the sun? Because to me, that's what it looked like. That is my question.
What, it looked like the moon?
Yeah.
You feel that day you did see the moon?
Yeah.
The moon.
Well, I think what it is, when you see a white shadow, when you see the actual shadow passing over it, you presume it is the moon. But I think from what research we've all done, I'm sure we can all agree that the sun and moon are a projection of some type from our perspective. So nobody's actually seen the actual ball rock moon pass in front of the sun on any eclipse throughout history. All they've ever seen is a silhouette of the sun, because the majority of people don't look at it with their eyes, and a shadow which passes in front of the sun. Now, I know the moon is in that exact position at the time, according to Time and Date and all the other mainstream sources. But as Chris and Mike Helmick have shown, there is no object passing in front of the sun. Yeah, that's what we're trying to explain here is, and I know Crow 777s come to the same conclusion, that after analysis, putting it through different spectrums and whatever you guys do with the Photoshop, there's no actual image of the moon.
Has Crow posted a new video, Dave, of his final analysis? I was trying to track some of his work. I watched it a couple of days ago, but has he posted anything recent that shows what his conclusions were?
Yes, he posted one yesterday, and I watched it last night, and it's pretty good as well. Yeah, he goes into it in a lot more depth. Yeah.
I just want to say, I think I realised why Craig has said what he said is because in his mind, in 1999, he saw the moon. That's what he thought he saw.
Yeah, I was going to say that because, like, obviously I was a lot younger.
The question was this actually an eclipse, or was it that someone had man-made that one? Because he thought he saw them, in his mind, I've seen the moon eclipse. Yeah,
to me, in my mind, that's exactly what I saw. The moon going in front of the sun, and that's it. And then I went home after it happened and so forth. But obviously, I wasn't awakened to, stuff that I am to now, so...
How old were you at the time? How old were you?
Well, I was probably in my 19s.
19s, yeah.
Yeah, so I was still young.
What he's trying to say was, do you think this was a fake eclipse? Because
I don't think
that was a fake.
I don't think it was fake. It was a natural phenomenon, but obviously it's not what we're being told.
Is the sun resetting?
Yeah, so it's like the flat Earth, isn't it? It's like it's not what we've been told. We've been told it's a globe. So now we know through years of looking at stuff and getting into it, like truth in general, we know it's flat, and obviously now we know it's not exactly the moon that's going in front of the sun.
Yeah, you can prove it in different ways too. Like if I'll share my screen here, I can show you some of the other work here too that we've been working on. You can come at it from both directions. You can say that I didn't see any object pass in front of the sun, and then you can look at the properties of the moon and say, what do I see in the moon that would forbid it or prevent it from causing an eclipse? And so from the other side of the fence, you can say, well, in all of the pictures that we have of the moon, when you do the photo analysis on those for the luminance gradients, there's some pretty strong evidence that the moon itself is actually translucent, right? Light passes through it. Right? When you do the gradients on it, you can see that it's coming through the bottom, exiting the top, and the shadows get darker as the light passes through it. This here is actually a picture of, this is a lunar eclipse. So the light came through the bottom and then caused the rest of it to go red. You can see that the shadow is not actually a straight curved shadow. It's actually it's being lit up from the inside and coming out in a different angle than the original. Right?
Chris, just on the back of that as well, on a lunar eclipse and all, what it does look like, if you shine a light through an egg and you get that red glow, you get the similar kind of effect from the actual moon on a full lunar eclipse as well. It gets that same kind of a red glow, doesn't it? And also, that's interesting.
Yeah, exactly. Like, so this is where I went to the red spectrum, right? So this is where the light was the brightest in the moon during a lunar eclipse, right? And then the next phase is I went and inverted it to the black side. So now you can see that there's a clear shell effect here. The light's still dark because now that would be the brightest. Now it's dark. And then you take it into the third phase with the 3 spectral analysis. You can see, okay, well, now this image, the light's passing into it, reflecting around the shell inside and creating like a double-sided, is actually being split here. You can actually kind of see that it's like a mirror image of itself almost. So it has that property of bouncing around inside of an egg, and that's what we're seeing. So if you assume that this data here is correct and your assumptions are correct, you can say, well, the moon can't cause an eclipse because if it was directly in front of the sun, the light would shine clean through it. Right.
Yep.
So that's the opposite side of the assumption.
So we're talking a bit of like a bit of glass going in front of a light.
Right. Yeah. If you had like an opaque type of object, like a lampshade or an egg passing in front of a flashlight, right, you would still see the light passing through it. So it couldn't cause a complete blackout of the sun. Right?
Okay, I'm with you now. Yeah.
But, yeah.
Chris, just on the back of that, Cass Kring did some amazing work last year in regards to the moon, where he zoomed in on some craters, and what he did, he dropped all the levels down, and basically the moon turned into like a cosmic web. It was unbelievable. You need to go and check that video out. It's unbelievable where he drops all the actual colours down, and you can basically see through it, and it's just all like a cosmic web making up the actual image of the moon. Brilliant.
That's what I'm doing here actually with Bradley Gillen's. I keep getting his last name wrong because I know Matt Gilman and Bradley Gillen, right? And they both send me pictures all the time, and when I hear the two in my mind, I keep messing up. But he knows who I'm talking about. Yeah. So what I've done here is I've taken this as
something very sweet. Yeah. I know that the eclipses happen maybe once a month. Stan reckon they happen once a month, even if we don't see them, because some of them are going to happen over water. It's when they happen over land we see them more. When the sun does that, is that the sun resetting itself? It will happen once a month, but is that the sun resetting itself?
When it does what now?
When we watched that video and you reckoned it went into sort of a void of black in the middle and no disk was moving around, it was right in the middle of the sun and then it disappeared into the sun like a black hole. Was that the sun resetting itself?
I don't think it was, and eclipses don't happen that regular either. They only happen about, I think it's about 4 times a year. So
right, okay.
No, I just think it's the light changing phase shift and just canceling out itself. It's like, those expensive Bose headphones that you can buy, right? And what they do is they listen to the outside environment. They record it for a split second, then they invert the signal to play back to your ears in reverse. It plays both signals on 2 different channels. What it's effectively doing is you're still hearing 110 decibels, but you're really not hearing anything because it just cancels itself. And light can do the same thing. If you shine it through a crystal, right, it just kind of warps itself, turns around and phase shifts, and then you see absolutely nothing. It depends on the angle that the light's coming through the crystal at. This is a good example of what Dave was talking about, the cosmic web of the moon. Bradley had sent me this picture here, and he just posted it actually, I think today too. So what he's done here is taken, like, I don't know how many shots, but it's like about 400 shots of the moon in one couple of seconds. It's just rapid fires, and then he stacks them to get more detail of the moon. And then when you take that image and invert it, you can really see some detail in what's there, right? So you see all these craters and shadows. This one's gold and this one's black, right? And the difference. And then invert it to see what's really there, you can see there's a big difference between what you're seeing as physical matter and what's being luminance and shadows. Like there's a difference. They just kind of flip-flop, which is fascinating, right? It's you can flip-flop between the two of them and figure out what's real and what's not, right? What's the actual surface and what's actually an inverted shadow. If the light's coming through a denser area and hits the back of a ball and comes back out the other side, then you get what looks like a stacked image of a shadow with craters inside the shadow. It makes it look like kind of like water or whatever, but it's basically the shadow hitting the back, bouncing back out the front, changing the color. That's the way it looks. And this is actually what the surface looks like.
I've got a question for you, Chris, from the chat room. It's Brad Stonewatt. Obviously, there's a theory about sun gazing, but what does Chris think about sun gazing?
Well, I've never done any amount of it, so I can't really.
It says when it has a theory.
Whether it's good or not.
I know Dave came on the show the other night, didn't he? He talked a little bit about sun gazing, and he says like it's obviously it's making him feel better. He doesn't have to use his reading glasses as often. But what he did say is you need to do it at either sunrise or sunset, and just build up to it. Do it like a little bit at a time. And I've heard from Fuka's camp last year, one of the guys who started sun gazing, and he doesn't need to wear his reading glasses often as well. He's actually changed his glasses because his eyesight's actually improved. I've never done it personally, but that's what they reckon. Just at sunrise and sunset for just start off like 20 seconds. Next day, build up to like 25 seconds, and then build it up until you're comfortable. If it starts hurting your eyes, then turn away from it. That's what David said on the night, didn't he?
I've also heard that it's best to do it barefoot.
Amy?
I've heard this thing that it's best to sun gaze barefoot.
Barefoot with your feet in the ground, yeah, he did say that as well. Yeah, correct.
Yeah, all those negative ions. Negative ions are really good for you. It's something they don't tell you. So they've got you in plastic shoes, which means that the negative ions can't go through the plastic to get to you, and you need the negative ions. They're really good for you.
I might start wearing stilettos.
Those negative ions, it's strange because they're called negative, not positive. Positive ions come out of the televisions, the computers, the phones, and we need the negative ions. They're really good for you. Look up negative ions. They've got us in plastic shoes. Everything's plastic and it won't go through the plastic, and that tiny little sole on the bottom of your shoe stops you getting those negative ions. And every day, a bit like sun gazing, like 10-20 minutes, you need to do the same with your feet on the ground, do they? Anyway,
I've heard this thing that it's a satanic sun worshipping cult thing.
Yeah, because they've got all the information, they know it's so good for you. You know what I mean? They're telling us it's bad for us and keeping us dumbed down, and they're doing it for their benefit.
They have done this, by the way, because what they said is the sun is really bad for you when it isn't. And, doctors are saying that if you're going to get cancer or something like that, you're going to get it. It doesn't matter whether you go in the sun. Obviously, you don't want to burn yourself.
Yeah, it's probably all the creams and all the stuff you put on to actually block the sun out what's actually causing the actual cancer. It's not the sun itself.
I know, it's awful, because what have they told parents to do? Stick factor 50 on their children. Imagine all those chemicals that go straight to those children's kidneys or livers, so it's all really bad, and then they wonder why the children are ill. Like factor 50, it couldn't be any worse if you tried.
Yeah, there is complaining that my son's nursery, when we send him to nursery, we had any sun cream on. It's quite warm.
And it's even worse than that, because we need the water. It isn't just because it quenches your thirst. There's things in the water you need for your body, and what have they done? We're drinking Coca-Cola, alcohol. So we're doing all those kind of things above water. Do you see what I mean? They're affecting everything. So the negative ions, they're telling you the sun's bad for you when it isn't. You need those rays. It's for your soul. It's for everything. It's for your well-being. It's food for your body. All these things are foods for your body that they don't tell you about. Unrefined salt. What have they got? Refined salt in everything. Crisps, the food you eat, the ready-made meals, when really you should be eating unrefined salt.
Can I just elaborate on that? Because I was watching a YouTube channel.
You're echoing.
Yeah, He's
not echoing my end. I'll put my microphone off. Hang on, carry on, Craig.
Yeah, I was watching a YouTube channel, and they had cereal in water, and they got a magnet, and they put it to the cereal, and the actual cereal was full in the magnet. So there's metals in it.
Yeah, that's because when you buy Kellogg's cornflakes and they're fortified with iron, they're not actually fortified with natural iron. What they do, they actually add iron filings to the actual cornflakes. I've seen them do it. They get the cornflakes in a big like vat, and then they pour in the iron, and then basically then he got an experiment where he got one of these big scrapyard magnets and picked the cornflakes up because it's fortified with iron, but it's actually injected, like added to the actual cornflakes part of the process.
That's crazy. And our kids are eating that kind of stuff. Do you know what I mean? Oh,
yeah, they reckon that Kellogg's and Nestle
never work in a French fry plant. You'll never eat French fries again either.
oh, don't say that.
Yeah,
I like my
I worked in a chicken factory for 9 years as well. You won't want to work in. You won't want to eat chicken after some of the horror stories I could tell you as well.
I know, I believe that.
Don't they like chemicals, like almost like rat poisoning in the children's cereals? It's poison that they're putting in the cereals.
Yeah, it's to dumb us down, isn't it? To get rid of us.
Yeah,
it's definitely to dumb us down.
On a certain level.
It's all to dumb us down. It's to control us one way or another, like with flat Earth. That's like when they tell this great big lie and don't tell us the truth, even about how eclipses work. With 2017, we're not like 1677 or whatever. We're 2017. We call ourselves the space age, technology. They haven't even told us the truth about how eclipses work.
Yeah, just on the back of that. Sorry, Karen, go on.
Well, I was just going to say, when they do all this, all they do all the time is take your freedom away one way or another. And we're in some kind of communism already.
Yeah.
Yeah, just on the back of that eclipse, you know that a NASA astronaut and the YouTube channel Smarter Every Day actually allegedly caught the ISS transiting the sun. Well, I did a bit of research into this, and I found out they was both in the same state, Wyoming. I know they was about 240 miles apart from each other, but I took a snapshot of both images and I analysed them both. Looking at the sunspots and looking at the path of the ISS, and clearly it was all faked. You know what I mean? The sun wasn't even in the same phase of the eclipse. The path of the ISS wasn't the same, and the sunspots were in completely different spaces as well. And 250 miles apart on a sun what's 93 million miles away, you wouldn't have had the sunspots change that much due to their. Do you know what I mean? That's the kind of difference I see with somebody shooting a sun sink between me and Portugal, or maybe even further, like me in America. You know what I mean? There was a good like 25, 30 degrees difference between the same sunspots. So clearly, I did a post on Facebook. I don't know if you've seen it, and it's a complete hoax. And just on the back of that, Mike Helmick took one of the images, put it through Photoshop, and clearly it's a fake. And also, Crow 777 did the exact same thing and come to the same conclusion. So they're always trying to push the ISS, push the globe. You know what I mean? To try and keep it all flowing. But like I say, a lot of people like myself and all you guys, we're all waking up to this nonsense. And also, if you see the fake X launch yesterday, same thing again. As it comes down to land, the section what comes down to land, just at the last minute, camera cuts off. You don't see the landing on the launch pad. What's the odds? Every single time that SpaceX lands, it's either from 20 miles away, you see it, where they just reverse the footage, or the camera loses satellite connection. It's a load of nonsense. And the sooner people wake up, the better.
Really, yeah, I think it is. And I think, especially when things like the eclipse.
Yeah, they're faking that. They're faking that whole thing. Yeah. The SpaceX is faking it too. Absolutely.
Yeah, Karen, I tried to send you.
Oh, go ahead.
Just a quick one. I sent you a picture the other day on the Sun and Moon group of a picture of the satellite, taking a picture of the eclipse on a globe Earth. It was just so funny. That's why I sent it to you, but obviously you didn't get it.
Yeah, I saw it. It's from the Discover satellite, a million miles out. It's a load of nonsense.
Yeah, exactly.
The best thing about it is, on other shots, they've got the moon in the picture. Now, when the sun's in perfect alignment, you know what I mean, for the actual eclipse, surely the moon would have been there as well, and you wouldn't just see the shadow passing like you do on the other Discover images.
Yeah, exactly.
And on the back of that, the Earthrise from the Lunar Reconnaissance Orbiter is Earth, what they used from the Discover satellite. And all they've done is copied and pasted it over a bit of fake landscape from the moon. You know what I mean? It's just all nonsense.
Yeah, exactly. It's funny how they're still trying to do it, though.
They will.
Yes.
They'll push that forever. Unless people start doing things about it. You know what I mean? I've wrote 2 letters to the UK Space Agency demanding what my tax money is going for.
Yeah.
Because a budget of 388 million, when people are losing jobs here, left, right and centre, I think it's atrocious.
Exactly.
They've got to waste the money.
It's a good idea. I think it'd be great if like a couple 100 million people did that and they just flooded with mail, right? To say, we demand our money back.
Yeah.
Right? Just do a cut and paste. Yeah.
I was talking with Karen B today on Messenger, and I've got an idea for an experiment. We're coming up to the autumn equinox. Well, I thought about, because I've got a sun filter now, I tried a little experiment the other night where I basically took a shot of the sun at 8 o'clock, and then I took one again later on that night at 7 o'clock. And one of the sunspots had rotated nearly 90 degrees from one point to the next. Now, what I thought about this experiment, and I'm hopefully getting quite a few people to do this experiment, is on the 21st of September, if we all catch the sun as it's rising as early as possible, take a shot, make sure your camera's level. I'm going to use Diopter to make sure my camera's completely level, at 0 degrees level, and the sun. Then what I'm going to do, hopefully 12 hours later, is take another shot of the sun. Because we know that the sun rotates like a wheel, and hopefully if there's sunspots what are visible, we'll be able to see the rotation within that 12-hour period. Because remember, on the equinox, the Earth plane's aligned to the centre of the sun. No field of rotation, because it should just pass in a straight line from a ball perspective. And I'm hopefully getting a few people on board so we can prove this is a quick, easy win. This one, like I say, if there is sunspots and they do rotate between 80 and 90 degrees, how the hell would that work on a ball? It's passing the Earth in a straight line on a straight path through the Earth plane on the equinox. What's your thoughts on that, Chris?
No, I agree, and I've actually did a presentation on that already. They definitely do circle. Like they're actually rotating from like 12 o'clock high to 6 o'clock, and then 12 to 6 o'clock going the other way. Like they're rotating it around in a circle. So you're
exactly.
right, it's 100%.
But what they'll do, they'll throw in, because it's the Earth's tilt. You know what I mean? We're tilted at a certain angle. No. 23.4 degrees, whatever, blah blah blah. But on the equinox,
the face of the sun, the face of the sun that's facing us is doing exactly the same thing that the moon does, right? As it goes across, it's doing the rotation, and it's the same face facing us, pretty much, near as I can tell, for a very long period of time.
Yeah, so I've already
the same face. The sunspots are facing us for two weeks, sometimes a month and a half, right? And you see the same set of sunspots, right? And every day they rotate. Clockwise or counterclockwise, depending on where you're at across the equator. If you're in the north, they go one way. If you're in the south, they go the other, which is exactly what the moon does, right?
Yeah, so that's what I'm going to be planning. I've already done a quick trial run where I took a shot the other morning, and then took one at 7 o'clock at night. And like I say, it looks like it rotates from about 1 o'clock. The sunspot was at 1 o'clock at 8 in the morning, and it's round at 4 o'clock by 7 at night. You know what I mean? It's just nonsense. How could that happen on a ball? You know what I mean? You imagine you're on a ball looking at the sun, it's rotating and the sun's going past you. Why the hell would it need to rotate by 90 degrees? There's no reason why. If anything, the sunspots should move a little bit across the face of the thing from our perspective. That's my honest opinion anyway. Or we shouldn't even see any rotation whatsoever. Nothing. We should just see it fixed from every location, really. At 93 million miles away, it should be just locked in that one position all the time, shouldn't it?
Yeah, it should only move the sunspots if they're stationary on the face of the sun, and we're rotating around it according to the ball model, right? It should only move 1 degree per day, right? That's the maximum motion you should see, because we do a 360 according to their math once a year, right? So 1 degree per day is maximum shift from your angle, right? Which is very little, right?
Yeah, very little.
Yeah.
Can I just ask a quick question?
Yeah, go ahead.
It's just like a sundial. You get your shadow on the sundial. Obviously, you can tell the time with it. Could you actually do that with the moon?
It'd be difficult. You'd have to have no air, light pollution whatsoever, and it'd have to be like a full moon, a really bright full moon, for it to be able to see the shadow on it. So it's going to be difficult to see it in the dark. You'd have to use some kind of equipment maybe to see it, but I think it would be possible, right? But,
yeah, I mean, that just came to me, and I was just thinking about the sundial in its significance of telling time and season via that, because it's a good way to know that where the sun is going, in which direction.
Yeah, the moon follows a very similar path to the sun in the actual sky, so you wouldn't really get that much difference. Obviously, it takes 50 minutes longer each day to occupy the same spot in the night, so you would obviously, you wouldn't be able to tell the time with it, kind of thing.
Yeah, Sun and Moon has a little video I put out on our channels. It says the sun is a clock.
Yeah.
Because of the way Chris will explain it, won't you, Chris? Chris? Chris.
I think Chris is gone.
No,
Oh,
it's
there's a-
there is a video that we discussed this very topic. So if you want to scroll through the page and find the one where it says the sun's the clock, and it's showing exactly what Dave's saying. The spots are going around in this.
I know the actual sun and the moon move like a clock, but I was more thinking of the actual sundial itself, because you get, as one of you was saying, like the sun and the moon has light, doesn't it? So it's like you can, on certain circumstances, see the moon on the dial itself, and you can see actually the shadow moving around. I was just thinking that aloud. Basically.
You should be able to. It might be a different time frame, but you should be able to put two sticks to the ground and measure the difference that they move over a certain period, and then calculate the speed of the change, right? And divide it just like you would a sundial.
Yeah, the moon's like loses 12 degrees and gains 12 degrees on the sun every every day. So, like I say, that's where it does it. From when it starts waxing from a new moon, it'll lose 12 degrees up to a full moon, and then the sun will start gaining on it by 12 degrees, and that's how you get your 29.5 day lunar sinusoidal phase kind of thing. Because it's interesting, because I've explained this a few times. The phases are related to the actual solar day. Lunar cycle, which is from tropic to tropic, is based on the sidereal day. That's why it takes 27.3 days to get from tropic to tropic and back. But to get from new moon to new moon, because it's based on the solar day, which is longer, it takes 29.5 days.
Okay, yeah, I see what you're saying.
While Chris is just doing that, Karen, I've connected with a guy today called Christian Duarte, and he's from Punta Arenas, right, Ushuaia in Argentina. Interestingly, Ushuaia is the furthest populated city in the southern hemisphere. There's nothing populated past that tip of Argentina, and it's at about 54 degrees south latitude, which is interesting because I've been searching for somebody from that location for a long time. He's not a baller. He's not a flat earth. He's a baller, which pointing. But I've had a little chat with him and talked about the weather and the sun in his location. And on their summer solstice, it put it here. It says the sun is they have in the summer. They have the sun. The day lasts for 19 hours. I worked at 17 hours on time and day, but sun cal. But according to him, it says in summertime the summer's days last for 19 hours, and also he's done a couple of star trails, and he gets the southern star rotation as well from his location, which is quite interesting because I wanted to build a little bit of data up from this location, because with it being on the exact opposite latitude as the UK, it's good to compare the two. If you want, when Chris has done his presentation, what we did the other night, where we went through the LRO visualization software, and I showed you how to collect the data on the moon culmination to actually monitor the moon speed. I did a little bit of fiddling about after that hangout, and I went on to the tip of Argentina and put the location into time and date, just to see if the sun and the moon are doing the exact same what I'm actually presenting in my moon race videos, like where it speeds up on the equator and then slows down on the Tropic of Cancer. Well, funny enough, I did a couple of readings on it, and it's doing exactly the same spot, 60 degrees, but obviously they're looking, obviously they only see it for a short amount of time when it's at 60 degrees, you know what I mean? We see for like 17 hours or something like that, the sun, when it's on the Tropic of Cancer, but they only see it for like 8 or 9 hours maximum. So, but interestingly, the data I collated from the UK matches up with the moon culmination from Ushuaia, is it? I can never pronounce it. Ushuaia, Tierra del Fuego, Argentina. So that's interesting. Now maybe when Chris is doing his presentation, I can show you that and how it is exactly the same. No matter the moon speed is same, no matter where you are on the plane, it'll still speed up and slow down, and it's not a perspective thing from each location.
I was going to say, yeah, you go right ahead. You go right ahead, Dave, because I don't have a presentation or anything to show. So you go right ahead if you want to pull up any diagrams or time and date and do your thing. Go ahead.
Can I just say, while Dave's getting that ready, series, I put another video that was sent to me, but I think it's about the eclipse in the chat room to play. Would you play it, series? Series, you're just going to get that ready.
There's one thing I was going to just to point out to go back to kind of where I was there before we go back to the moon here just for a second, just to show people sometimes it's more important to ask yourself the question, what is it that I'm not seeing that I should be seeing, right? When you're trying to analyze photos and things like that. So in this image, it's back to Brad's image again. If it was in fact a solid object, right, you would expect to see, like we do on any solid object that's being illuminated that has any reflective properties whatsoever, right? You should see in some area relative to the light, probably here, that little light spot that reflects off the surface of anything, right? And it's absolutely you never see it on the moon ever. And when you do the analysis on the light, you can see that it's actually on this very outside periphery backlit, and then kind of there's no light here, it's being backlit here, and the light's being amplified on the other side. So you can kind of see that it's actually passing through it and being reflected more than it is on the surface. In fact, that's why as the shadow crosses the moon, the detail is always with the shadow, right? The craters always have the most detail where the shadow is, and then you'll see it as it passes, the detail is lost because now this is now being canceled. The light's being canceled out. It appears flat. It flattens the image because the light's being turned around and coming back to you in a straight line, right? And this light is coming across the surface on an angle, but the light's actually coming through it, right? So ask yourself, what is it that I don't see? I don't see any reflective light balls, or what they call that, there's a special name for it, anisotropic glare or whatever. Right? So if that's not there, that should give you a hint that the object is actually translucent. It's absorbing more light. Right?
What's the sun doing then?
As in?
Well, if one's absorbing, what's the sun doing then?
Well, the sun's definitely an emitter, right? The moon does appear to, in some cases, depending on how it's angled or facing and whatnot, it actually seems to have its own light to some degree, right? It's obviously not as bright, but I think it can do both. It can emit some light spectrum and reflect others, and then polarize some, and then change the angles. So it's doing all kinds of fancy things, but a solid object just can't do that. Right? It's impossible. Right?
Yeah, that's. I've caught quite a few of these images like this. It's quite common to catch that like that. There was a lot of people saying that what is it kind of thing, but obviously to me it looks like the actual. I don't know what your thoughts on that, but it looks like that moon image what I show. The one where you've got the overexposed moon and it actually projects a perfect image of the actual object.
Oh, like the double exposed one there with the telephone poles and whatnot, or the
the one where it's got the overexposed moon, then like an angle, you've got the actual red moon where it's actually produced the actual image on the actual reflection.
Yeah, and that tells you it's basically bending the light, right? It's being polarized in a certain direction and projecting into itself, right? It's got some amazing properties. Yeah.
I'm sorry I went a little bit quiet then. I put another link into chat because someone's that link there, these get sent to me for Chris to see. So this person wanted you to see this, Chris, although they don't have any subs, but they wanted you to see it. It's about well anyway, play the video. Series will play after this one. Craig Cox it is. That's the name they're using. Anyway, that's not this one, it's the next link. Series will play. So what's that then, Chris?
Yeah, is that particular extra object at the back apparently reflecting on something else instead of the lens?
You sometimes get that effect when you shoot through a window, or you've got like some kind of telescopic lens on your phone, and these gadgets you fit on it.
Outside, he just showed it where he is.
Sorry, I wasn't looking at the time.
I can show you.
Somebody's got some trickling water.
Yeah, that's me. It's the fish tank. Sorry about that.
That's all right. I could just hear it. I thought, it sounds like a pond.
I didn't know you could hear that.
That's all right.
Coming over.
It's just got a toilet, haven't you?
That's a long way.
It's keeping me calm.
Austin Powers, evacuation complete.
These are really lens, but this is not the lens. This is actually parallel to what the sun itself. And you can see the lens flares move over the image, and the other one is static with the sun. It's the same one what we saw, but then with that red moon, red light.
Now, what's interesting when you're done playing that video, I'll show you what's interesting about that particular effect right there, that half moon or crescent moon type shape. You can see how it's coming, like during the eclipse, that's appearing in the sky. Obviously, some of those are, depending on the angle of the camera. Some are moving around relative, right? One's flipped upside down. So the one that's flipped upside down is a lens flare. The one that's actually right side up with the crescent on the top. So that's a lens flare right there. This one here that's not moving.
Can't see where your cursor is.
Right.
Yeah, I can see it. Yeah.
I'm just talking about the video here, right?
Yeah.
As Series plays that video.
Oh, I see. No, I thought you were talking about your picture. Carry on. Sorry, we're back on the video now.
Right. So that
when it jumps across each other, is that reflection?
Yeah.
Yeah. So the image there that's right side up, that's not as bright as the reflected, but that image right there that's right side up and it's dark on the bottom is the actual object, right? And the one that's bouncing around that's upside down is a reflection, and that's flare lens in the camera. But this one that's remaining stationary relative to the light source is the real object that's actually being forward projected onto a stationary plane, right? Or a stationary level that has, so the camera's seeing something that's real, right? But it's still being projected forward and appearing on a refractive medium. And then the camera's picking that up as a secondary image and making these lens flares. And I'll show you what's interesting about that. Is these pictures here, if we can pop them up.
Okay, I see what you mean, yeah.
Right, so that image in the air, the lens flares are also being cast down to the ground by the millions, landing on shadowed surfaces, right? Thousands of people got these pictures of the moons, right? On the dog, the spotted dog, right? That's awesome.
Do I've got to say, I've never seen these kind of things before.
I haven't until Chris showed them to me.
Yeah,
Right, so
I've seen it, yeah. It's interesting, isn't it?
Definitely.
How it does that.
How does it reflect so
like
many, like in one place? Do you know what I mean? That's crazy.
Because it's coming through the tree.
This is the interesting.
Oh, the tree, yeah, no, that makes sense.
Yeah, it's shadows through the tree, but it's still interesting that in order for it to do that, you have to just kind of think logically about it. In order for it to do that.
The funny thing is, it looks like clouds.
Right.
Yeah, it does a bit.
This one's got Schrodinger's cat in the background. Can you see the cat? Right.
Yeah.
Is it dead or alive? You have to ask yourself the question. Right?
Weird.
But it depends on the angle of the photographer and where they were during the eclipse, what angle that they caught. Right. So that in itself tells you one thing. Right. If you just pause for a second and think, how is that possible?
Yeah.
That some people saw them as small images, right? And then depending on where you were at the time, right, the angle is completely different. They're stretched out, right? And ask yourself, can that happen on a ball?
Yeah.
Right. And the answer is, well, no, you can't do that on a ball, right? Right.
Can I just say, Craig?
It has to be an angular thing where that light source is acting like a laser and projecting it forward in front of itself. Millions of these images, right, from all different angles, because the light's passing not just through a tree, right, but it's passing through in multiple renderings of the same thing, all from different angles. Right? So that's another part of the study. I'm going to try and put together a presentation on to explain why this technically happened. Right?
Yeah.
Can you explain, Chris, why this happens through trees?
From many angles.
You've got pictures, haven't you, yourself, of some things that you've taken. And then when the light was coming through the trees, the apples appeared where the light was coming through the trees. That's where the apples grew. So is that the same sort of thing? What is it about trees that happens that can do that?
Oh, it's interesting, yeah.
Yeah, the leaves must be just splitting the actual light.
Whoa, to leaves then.
Yeah, the small gaps in the trees, right? Because there's so many little tiny pinholes, essentially relative to the light coming through the tree. It acts like a pinhole camera.
About the leaves as well, yeah.
Well, just the space between the two leaves, and there's just a space between two leaves, right? And it causes the shadow.
Oh, okay, yeah, I see.
The light between leaves.
Yeah.
The light between the leaves acts like a little tiny pinhole camera, right? You know how a pinhole camera, you can look at an eclipse, pop a pinhole in the box and shine it down on the paper, and you'll get a perfect eclipse picture.
Yeah.
Right.
Wow.
And that's not abnormal. That's not abnormal. What's abnormal is how is it doing it from all of these different angles?
Yeah,
right.
Of course.
That tells you that the image is coming from multiple sources or multiple angles all at the same time, right? It's not just one emitter. Right? It's being refracted through something. It has to be being refracted through something with multiple instances of refraction.
Well, like you could say, like it's sort of bouncing off of the dome and then hitting multiple places.
That's kind of where I'm going. That's pretty much where I'm going to go with it. Yeah, it's bouncing, coming through a dome, like convex lens.
The sun's projected to each observer's location, isn't it? It's like when you go down to the beach and you walk across, and the line follows you along. It's on the similar lines to that, I would have thought.
Because the only way to project an image like that is to pass light through a crystal. Each individual crystal creates its own holographic image.
Well, that's very
depending on the angle of the crystal.
Yeah, the sun and the moon, there's like the perfect hologram.
Yeah.
Hey, Jamie, what do you think about those pictures then?
Interesting.
Have you seen any of those before?
No, I can recall.
Wow, I just think that one. Wow.
I've never seen them before, even on previous eclipses, like when people have footage. I mean, this is all new to me as well, but it is very interesting how it does that. It's unbelievable. When I first saw the first image, I couldn't get my head around it at first because the image they didn't comment on it, so I was like, "What the hell's that?" So, but yeah, very interesting.
Trees, then, if trees can do that, like reflect light like that, that's why, you know, in those high altitude balloons, it doesn't matter whether it's water or land, balloons looking down onto the flat plane, everything, the clouds, the land, the water, everything is really bright, you know, with light. I mean, there's light, masses of light coming off of us.
Yeah, go on.
Go on, Series.
As a reflective medium.
Yeah. Can I just change the subject a tiny bit? Series, in the chat room, there is another video which Craig Cox wanted Chris to see.
Yours, okay.
Steal it, I don't care.
So we're looking at the Earth there in that picture there.
I was wondering if you could pause that maybe just for a second. I wanted to show you, before we jump into that, just to kind of stay on topic here. I wanted to show you something about the trees here. You guys might find interesting.
Wrong button.
Oh, he's gone. And me and Series also unpresented him and presented him at the same time. So you presented him. And now he's gone. We didn't. Okay, then, Series, carry on playing the video then.
Okay.
Oh, it's for Chris. He wants Chris to see it. Right. Chris, where have you gone?
He's had it on his toes.
I may hope it's not an object. No, only hide from both.
No, because we both. Oh, he's back. Phew.
He's back.
Chris, where did you go?
Oh, wrong button. I was trying to share the screen and I put myself out of there.
Me and Series thought we'd ejected you or something.
Now, where's the group?
Chris has gone in again, isn't he?
Oh no, he's done it again. Technical problem.
What is going on?
We've always got to have a technical problem. You know, like Dave manages to share his video all the time, and then he has to do it on Sun and Moon. I can't do it.
We'll get it this time. Yeah, I'll get it this time. Okay, I just wanted to open this up and then
press the wrong button.
Full screen here. There, can you see an apple tree? Yeah.
Yep.
All right. So you should see an apple tree full screen, right?
Yeah.
Okay. So this is an apple tree that's in the backyard here, and the sun was just going down to the west and just on the horizon, and it hit the center of the tree just perfect. And you can see that it starts to take a shape in the center of that tree as the light passes through it. And then the camera just went slightly out of focus in the next one, and you can see all the little circles coming through the tree, right through the backdrop of the tree, through the leaves, and then an apple starts to form in the center of the heart of the tree. The way the apple tree is making the shape.
Can I just say as well, like looking at that picture, they look like stars as well.
Yeah, exactly. And so you see, it starts to make an apple, and all these little circles here. Then as it gets out of focus, this one here, you can see that it actually starts to form. You can kind of zoom in on it, maybe you can grab a screenshot, but you'll see a little vortex of light that looks like a rose in the center of the tree with an apple in the center of a rose, and then all these little, they call that collimation, right? Collimation and refraction, but it's like a laser beam. If you look at a laser beam, it starts to make these little circles as it becomes more diffused and more out of focus. So it's the collimation effect that causes these types of things. But I thought it was just amazing that, there's an apple in the heart of the tree, of an apple tree.
Yeah.
And basically what happened was, what was interesting too is when I went out later on in the season, I looked at this picture, then I went out and looked at the tree, looked at the picture, looked at the tree, and pretty much everywhere where one of these little circles was, and that's where they grew.
Wow.
Right. So it would make sense probably to me that if this is the way the tree gets the light and it passes through the tree, then where these light points focus in the tree, because the apples need light to grow, then they would tend to form and bud, relative to where these light points are most.
Well, see, that's how you know there's a creator.
Most light.
We can't just come from a big
for
bag.
Sure.
Did you get a super apple in the middle?
Well, look at that, right? I mean, what are you going to... Yeah, I don't know. Well, the tree, an apple tree looks like an apple, right? I mean...
Yeah.
Just thought with that one in the centre, you got like
an apple tree.
Like a big Granny Smith or something.
Yeah.
Definitely.
Yeah.
And actually, the middle of an apple is like a vortex anyway, isn't it?
Yeah.
The core.
Yeah, there's the one that I zoomed in on the vortex. Yeah, so there's the actually kind of see almost like if you look at a magnetic field, like and a magnet spinning on a piece of paper and you spin a magnet, it starts to build up these like rose petal buds also, and when you spin a magnetic field, right? So to me, it's like, well, okay, the light passes through the tree, making these magnetic fields, and light causes form, right? Because if the light creates a magnetic field, and then the apples grow in the shape of an apple and an apple tree. I mean, you can't deny that it's the light, right? right? The light is causing that to happen, right? It carries the information. The information is right in the tree, right? Just blows the mind, right?
Definitely.
There's the creator, right?
Yeah, that's how we know there's a God. Definitely.
I wonder why iPhone have an apple for their logo.
I wonder why, with a bite out of it,
That's Adam and Eve, isn't it? Really, essentially.
Doesn't the Apple logo actually have a bite out of it?
Yeah, it does.
Yeah.
Well, it did, unless the Mandela effect has.
Yeah. Oh no, the bite's still there, as far as I know.
Also, it's making it's an amazement, but everything's just like my whole place I live is completely changing. Everything, even now to like moons coming through the leaves and apples coming through the trees that aren't even there yet.
Yeah, I mean, just tonight alone.
Thanks, Chris.
Everything tonight that I've just seen, I haven't seen before, and it's just changing all my perspective from what I knew just a few, minutes ago, right up to this point. It's really crazy.
Oh, Craig, I'm really glad you came on today then.
I am.
Thank you, Chris.
Yeah, I've got some crazy stuff to show as well in a bit on this research what I've been doing in regards to my moon race as well. So that'll be interesting. Shall I kick that off now, shall I?
Yeah,
can I just say, can Series just play that little video for Chris? It's only a couple of minutes long, and then after that we'll go into your stuff, Dave.
Yeah, fine. Perfect.
Right, Series, you can play it now. Series? No, where's Series gone?
Have you previewed it for content? I don't know what we're watching here.
Yeah, I know what it is. Series, we played the video. Play the video now.
Yeah, just wondering if you knew it was actually the content. Just be careful what you're randomly accepting from the audience for videos, right? You never know what you might see.
Yeah, it could be anything.
Well, I just wondered what you thought of what this person was trying to say. I hope I saw it the right way now.
We're looking at shadows here, aren't we?
Yeah.
Yeah, it's just like the sundial, really, isn't it?
It's actually on the post, but because we presented it, you can't see the actual video name.
Yeah, that's why they put the 23.4 degrees tilt on the Earth to give you that arc.
I asked him if he was going to do it. He said he did whatever. I can't remember now the reason why he said he couldn't do it. But he couldn't do it. But anyway, that's his idea. So, Chris, for you again. What do you make of that then?
I'm not sure what's trying to be proven here, really. But is he trying to prove the globe, or disprove, or prove the flat, or disprove the
I think he's saying what he's saying is the sun moves in a certain way on a flat plane, and it moves a different way on a globe. So if you went to that place and did that test, then you'd know what it was for sure. But I'm sure he's a flat earther because he's put that in there the way he has, because he believes it's flat, doesn't he? But that would prove it were flat. But anyway, most of us won't be going there, will we? Because we haven't got the money or whatever it is. But it's his idea. He just wanted me to show it to you to say, what did you think of that?
Is he just talking about the shadows and the way the sun moves?
It'd be a good experiment to try. Yeah.
If I unpresent Series, the actual name of the video should be there to how he's put it. If I unpresent, does it come up on Series? No, it doesn't. There's no name there below. There's no name on there, is there? Series, there you go.
I can't see nothing.
He says flat earthers explain this. So it wasn't a very good video then, was it really?
I'm not sure what the proof is trying to be made there. I'm not sure exactly. But
get rid of it, Series.
On a flat plane, if the sun is coming through a toroidal focal point, then the shadows would be relative to the focus point on the flat plane. Whether it rotates in an arc, comes across the equator in a straight line, you'll get a straight path. If it's south of the equator, you get a curved arc. If it's north of the equator, you get an arc, because it's actually a focal point and a rotating ball, right, of energy coming to a focus point above your head. It has nothing to do with the shape of the object below. So the premise there doesn't prove anything really. It'd be an interesting experiment to do though. But it's the path of the light. It's the path of the light and the path that the light travels that makes the shadow. Right. So it doesn't matter what shape the actual object below is. What I think about it.
The sky doesn't move the land.
Well, that's why you can't triangulate the sun, right? You can't triangulate it anyway because it's coming through a refractive medium on more than one level.
Yep, and it's always projected towards the observer as well. So, like I say, it always appears in that exact spot in the sky. You know what I mean? The other person, 20, 30, 50 miles up the road will see it projected in that spot of their sky as well.
Yeah, one sees it at the equator and the other sees it in the night at the other side in the north. How does that work?
Yep. The only way that works real good is if you have a nice refractive dome above your head that's bouncing light around and having it to focus at different points at the same time relative to the observer on the ground. That's why you can't track it. You can't triangulate it because it's outside of the boundary.
Anyway, at least the eclipse was a bit like repeatable, observable. Yeah, this time round on things like that. So you can only go on what you can see.
Yeah, it was observable, measurable, repeatable. Well, not until 2024, is it?
It's amazing that, like, I think it annoys us, doesn't it, when you think, like, I saw that eclipse and I thought it was the moon eclipsing. It's 1999. I remember that. I know where I was looking at it in my garden. And then you realise that everything is just so different. You didn't see it anything like you do now.
I remember being young and looking up into the sky. I think it was in the 80s. I'm talking like early 80s to mid 80s, and seeing a red moon and asking my stepdad, what is that? And he said it was either like Jupiter or Mars. Yeah, it was Mars. That's what he said to me. And I was like, okay. And I just agreed with him. Okay, fair enough, because obviously he's an adult. I'm just a child. Do you know what I mean? So I don't even know what it was even up until this point.
Can I ask a question then, just even in the chat room, right? Because I was small, but does anybody think that when they were young, that the moon was much further up in the sky than it is now? I'm not saying that we didn't have the harvest moon or something like that, but I remember the moon was this quite a small thing in the sky. We see it now. I just wondered what everybody else.
To be honest with you, I've never really so much noticed the moon until about a year and a half ago. So I can't really comment on that. Just one of them things what never really bothered me. Obviously, I knew it was there, but I couldn't tell you when a full moon was or when a new moon was or anything before then.
What about you, Chris?
As far as which?
When you were smaller, do you remember looking at the moon and thinking, "Oh, it's quite small up there"? Whereas now we just get very often, or here in the UK, we get quite often big moons. I mean, quite big moons. Occasionally, it's frightened me to death. It's that big. It's huge. I mean,
when I was
really
younger,
huge.
well, I don't know. I think when we're kids, it's kind of like the Charlie Brown show. Like your parents are giants, and everything is bigger, different sizes. And as we grow, it changes. Yeah.
Except chocolate bars.
Yeah. Remember that?
Cool. I remember going to the pictures and having toffee logs. You don't get them anymore.
I remember buses.
2p they were.
I remember buses being 10p.
Yeah.
I remember being 2 pence.
Yeah, I always thought that was brilliant in the Charlie Brown show, right? The teacher never actually spoke any language, right? So the kids were actually talking to themselves in child speak, right? And ignoring the teacher, but the teacher always sounded like, wah, 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 right? And it was like, right? But yeah, Charlie Brown understood the teacher, but then he talked to his friends in the foreign language, right? Kids, right?
Yeah, I didn't even see it like that. But yeah, you're right.
That was genius, yeah, because
Definitely.
the innocence of childhood, yeah.
And Toffee Strip. Do you remember? Anybody remember Toffee Strip?
I don't know where you're from, Karen, but I don't remember that.
Yeah, you're younger than me, guys.
I'm
Like the butterscotch toffee strips you used to buy in the box with the wax paper and the.
Didn't they look like cigarettes?
When you were a little kid and you had a packet of sweet cigarettes. Not maybe when you're about 10. I mean, when you're little. I remember thinking.
Yeah.
What do you mean? I had a proper pack of cigarettes.
Oh, dear me.
Oh,
We're funny tonight. Well, actually, Dave tonight. And Chris.
Yeah.
Yeah, and we haven't had any music yet.
Right, so this presentation then, Karen.
Great.
I can show you something too as you're loading that up there, Dave. Here's something I'm going to share. Just to play. I'm playing with it just to get your ideas and thoughts on it here. What I've done is I've taken a full moon image into Blender and I put it inside a glass ball so I can spin it around and see what happens to the image, right? To try and see what phases shift and whatnot. And I'm also trying to see if I take the image and put it down onto a mirror below, right? So you can actually tilt it, see if any of the images line up as reflections of themselves. Trying to figure out how it acts the way it does as far as being a translucent type, see-through type of object, right? Anyway, it's just fun trying to figure it out.
Yeah, I think it's the toughest nut to crack.
Yeah.
It's like a cookie.
It is a cookie. It's a chocolate chip cookie. And it's also a beef burger.
when I saw that and someone put up it's a cookie, I was in stitches. It hurt my stomach.
It was really strange because that was like Chris was talking about it and doing a model where he thought that's what the moon looked. I was going, wait a minute, I've got pictures of it, which I put on Sun and Moon about December, showing it as when I saturated it just with a bit of colour, a chocolate chip cookie thing. It could be a ginger nut biscuit.
No, more of a cookie.
Yeah, better it's a cookie. But then it was just exactly what Chris was talking about. It's like, oh my goodness, my iPhone that was from.
That was funny though.
Yeah,
This one
so
here
so carry on.
Here's another one I'm trying to work on. I don't know if can you see that on your screen there, maybe?
You're being presented. Is it there? It's black. There it is.
Yeah.
So what this is let me just toggle that on and off here a little bit. So what I did is I took a picture, one of the pictures from the eclipse, right? This is a previous eclipse, not the one we just had, but I'll do the same with it as well. And then I just put in the toroid magnetic fields to see if I can line them up and how well they would line up to see what the magnetic field is actually doing. Right, you can line up the charge to see how they would actually line up.
That actually looks like
predict
sound waves or something along them lines.
Yeah, like if you take like in a ferrocell, take a magnet. If you look at some of Ken Wheeler's work online there, some of his videos, take a ferrocell and a magnet, put the magnet underneath the fluid. It'll make that type of toroidal shape from the top looking down. It makes that type of shape. So we can tell that during an eclipse, whatever is going on, we're kind of looking through it on the side reel, because the magnetic fields coming out of it tend to be this sort of a side donut shape. So it's actually spinning in the opposite direction, and we're getting a cancellation of the light because now we're looking through it on the side reel. So that's kind of the conclusion of that. Just like you might find that interesting, how I'm trying to figure this stuff out. But, yeah.
We're living in this crazy
Think of that, Dave.
We're living in this crazy place, and if they ever made us believe that space was this futuristic thing, the thing we're living in is the most futuristic you could ever be.
Yeah, definitely.
It's just absolutely incredible.
What blows my mind the most is, how it's so complex and yet fundamentally so simple.
Yeah,
right.
Definitely. I like that. That is good.
Yeah, the Trinity, right? That's all you need is a Trinity, and then you can create everything out of the three.
Yeah,
right? It's just amazing, right? Amazing, right?
It's a beautiful thing.
3 states of temperature. Yeah.
So, can you see my screen?
Yep.
Yeah, 1 minute. Yeah, we can, Dave. 1 minute before we go on. I mean, look at our bodies. Look how amazing our bodies are, for goodness sake.
It's even the fact that we could reproduce kids. It's amazing, and the way it happens. It's a beautiful thing. How can we just come from nothing to something? It is all design.
Infinite division, right? Infinite division, not perpetual expanding Big Bang explosions. It's infinite division into fractal reality. That's the only way I can think of it that works. Yeah. That's another thing I think they're trying to.
It's a bit like a figure out. I'm not sure if we're living in what do you call it? We're living in virtual reality. It's just virtual reality. Our brains are in these bodies, and we look out, and everything's virtual reality. Well, I suppose that's correct anyway, because we live in the now. But anyway, Dave's got his video ready, or his information, so go for it, Dave.
Yeah, so just a little bit of background first. What I've done, I've done quite a few moon observations to try and record the speed of the moon. Now, the method I use is quite crude, because basically what I do, I record the moon when it's on the tropics and the equator, and as it enters my frame, I use that as a timescale till it gets to the other end of my screen. And what I noticed is, just on the actual observations themselves, is that when the moon was on the Tropic of Cancer, it went at one speed. Then when I recorded it a week later on the equator, it seemed to speed up. Now, I thought that's interesting, because at the time I was still supporting the AE map and for that model, because that's what it would need to do. It would need to speed up as it went further south to cover more ground, obviously, on an expanding circle. So what for 6 is when I recorded it on the Tropic of Capricorn, and it slowed down significantly, very similar to how it similar speed to what it is when it's on the Tropic of Cancer. So that got me scratching my head, and so I made another video called Moon Race 2 where I tried to explain why it does that. So what I thought I'd do first is just run through the actual first little bit of Moon Race, the observation side of it, just to give you an idea of what I was doing and how I captured the moon and how I recorded it. So basically what I did, I went on time and date, and I found out when the moon was on the Tropic of Cancer. And how you do that is you just look for the closer it is to the north. So the lower the degrees is, that should the point where it's high on the Tropic of Cancer. And obviously you can see I took plenty of readings, took snapshots on stellarium, then compared it on the following night as well to obviously give me a time frame, because if you record the moon in one spot, then you record it on the exact same spot the following night to measure that time difference in between. You've got to tell the time scale there. And what you can do then is you can go onto time and date, and you can look at the meridian passing on there on the same night, and then on the following night, look at the meridian passing again and measure that time again. And that's what I did. And what I found is my observations, even though they're pretty crude on screen, were matching up with what time and date was actually saying. Like, so the observations I'm actually making in reality are matching up what the actual moon is doing. And as you can see, the moon is where it says it is. I've took Dr. readings as well to compare with time and date and mooncalc, and my readings are normally within 2 or 3 degrees. So it is pretty accurate. And not only of the observations I made on this video presentation, I've made hundreds and hundreds of observations where I've seen the moon, I've took a Dr. reading, I've clicked on time and date, looked at the azimuth, looked at the altitude, and it's very, very, very similar to what I'm capturing on a phone with a free app. So the app is pretty accurate, and as you can see in the moon race experiment, that when the moon is on the equator, it travels at a faster speed. Now you're probably thinking, maybe this is just because of from your perspective. No, this is same from anywhere on the plane. It doesn't matter if you're in the North Pole, the South Pole, whatever. That speed is consistent everywhere. It's not just related to my observation point. Now you notice the time on the Tropic of Capricorn was quite a big gap, and what I did notice is the actual radius of the moon as it gets southern declination from my perspective, and I presume that from a southern location, when the moon's high on the Tropic of Cancer for us, the moon will shrink to their perspective as well. So there is actually a difference in the moon, which actually I've spoke to Chris about this, and hopefully when I do my new video we can work out that actual time difference. It's not a major difference, you know what I mean? It does make a little bit of difference, but I wouldn't thought you're talking like minutes. I'm thinking you're talking seconds, because it's only a fraction smaller. So what I did here then as well, I did some time lapses when the moon was in certain positions, like on the Tropic of Cancer and on the equator, just to show you what the moon's actually doing when you actually capture it in a time lapse sequence. So when the moon's high on the Tropic of Cancer, well, this is interesting one. This here, this is showing you the star trails from the north. That's the one I took, and that's one from my mate Paul Cofo in New Zealand. So what I did then, I captured the moon, the Tropic of Cancer, and what you'll find out is it'll appear to rotate around the northern vortex. Then when the moon's on the equator, what you'll see is it follows a very straight path. And then when the moon's low on the Tropic of Capricorn, from our perspective, it'll follow that arch round, similar as the star patterns are doing. And there's just another snapshot of what you do. You in the northern hemisphere, on the equator, and in the southern hemisphere. So you've got that kind of pattern. And I'm sure Stan showed the similar kind of effect. So what I did there, I just said that, so when the moon is above the celestial equator in the north, around the Tropic of Cancer, it's circling in the northern vortex. I should have said vortex then, but and when the moon passes the celestial equator, it will pick up on the ethereal currents on the opposing vortex. And when the moon is below the celestial equator, around the Tropic of Capricorn, it is circling the opposite direction in the southern vortex. What I did to try and, I'll just show you this other video now. If I click on another video, will it come up? I need to just open another video, that's all. Right.
If you close the window, you have to actually reshare.
Okay, yeah, no worries. I'm just getting the
Sorry,
moon
guys. I've got to go, so I've got to say goodbye.
Okay, pal, I'll let you get off, and I'll just get this ready anyway.
Okay, then. Take care, guys.
I'm gonna get off myself as well.
Who's leaving then? Craig's going and Jamie's going.
Yeah, I think I'll say goodbye. But
yeah, we do quite a lot of sort of research stuff on here, Jamie. I know that on your chats you talk a lot more, don't you? You know, you talk and talk and talk, whereas we're sort of researching and looking at things. Was it okay for you then? Was that not your kind of stuff?
Fine. But yeah, there's not really much I can add, but but thanks for having me on anyway. But
thank you, Jamie. And Craig?
Yeah.
Did you enjoy that then?
I'll see you guys later.
Enjoy the what we talked about tonight?
Very illuminating, definitely.
Well,
so can you see that?
Yeah, thanks guys. Nice meeting you guys, and you guys take care.
Thank you,
You
Jamie.
too, mate.
Thank you, Craig.
Yeah, cheers.
Can you see my screen?
So I just say, then I'll let you get on with it.
Thank you, darling.
Bye.
Bye, darling.
Can you see my screen, Karen?
Yes, it's presenting.
Yeah, so basically, when I caught the moon on the 6th of March, what I've done, I've stopped the moon phase 2017 visualization from NASA on the same day, and obviously you'll see the moon's in the exact same phase. Interestingly, this is when we had the moon high on the Tropic of Cancer, and I've looked into this now. Now, if you look at it on this actual little moon here, it says it's pretty level with the ecliptic there. So I don't know what's going on there, to tell you the truth. So it don't make no sense, like I say, because we're seeing it high on the Tropic of Cancer. But according to that, it looks pretty level to me. But anyway, as you'll see, when I caught the moon, when it was on the Tropic of Cancer, it's pretty much around the Tropic of Cancer on this actual this distance chart here. But as I've documented previously, the moon speeds up in this phase here. Yeah. Now, in the heliocentric model, what you'd find is when the moon's at this point here at 28 and it's at its closest, it's called perigee, and when it's at its furthest point at 32 Earth distances, it's called apogee. Now, according to the heliocentric model, when the moon's going from perigee to apogee, it slows down as it gets to its furthest point. Then, according to the theory of gravity, what happens is it's pulled towards the Earth again at perigee, where it starts speeding up by about 6%. Then, as it passes the point there, it'll slow down again and it'll repeat that cycle. So, as you can see there, that's the first point. But when I stopped the moon on the 21st, the 12th, which was a full moon, smack bang on the equator at the time. There, yeah, I know from all my time and date readings that the moon was on the equator, but according to that, it's at that angle there. Like I say, I'm still trying to get my head around that, what that actually means. But as you can see, it's around the equator there as well on that point. A little bit off light, but it does vary. It doesn't actually go to 28, 32. It varies along that line there. And then when I go to my last observation on the 21st, there you go. Obviously, the moon is around that vicinity at its furthest point, but from our perspective, it's low on the Tropic of Capricorn there. Now, I think I mentioned this before. What NASA are trying to say is that this distance here doesn't affect the height of the moon. It's down to this actual 5-degree inclination, which is equivalent to the Earth's 23.4 degrees tilt. Yeah. So what they're saying is it's down to that why we see the moon high on the Tropic of Cancer and low on the Tropic of Capricorn. But in reality, anybody who's done a little bit of research these days will know that when a celestial object is closer to the observer, it will appear higher in the sky, and when it's further away, it will appear lower. So that's where I'm with that. And like I say, in their model, it should speed up now as it's going away. But we know from the observations I've made and the data I've collated over the last 7-8 months, that the moon will speed up from its closest point on Cancer up to the equator, but then it will slow down to Capricorn. But interestingly, then it will stay at the relative same speed all the way back, and it repeats this cycle. This is not just why it does it every so often. If you take culminations of the moon throughout the year, you get the exact same cycle within a couple of minutes of each other. So what I thought with this moon race experiment, because I've captured the moon on 3 occasions in August, where I did it backwards this time. I started from the Tropic of Capricorn onto the equator and did it backwards to hopefully show. I haven't edited the videos yet, so I don't know the times on them, but I'm hoping they're going to all be the relative same speed. So hopefully it'll show that what I'm documenting in reality, is happening according to the time and date of the moon culmination. Now what I did, I'm just going to close that window there, and I'm going to go on to time and date now, and I'll just minimize this a little bit. Present the screen. Can you see the screen? Okay.
Yeah, we can.
Well, like I made all my observations from the UK, and I showed that the times from the meridian passing I've taken on the 6th match up with what I've been doing in reality. So from the UK, when the moon's on the Tropic of Cancer, it's going at its slowest speed, and then it speeds up towards the full moon on the equator. So what I've done this time, I've changed it around a bit. I've gone to Ushuaia, if that's how it's pronounced, which is on the exact opposite latitude as the UK. So it's about 54 degrees south. And I'm going to show you now that it doesn't matter where you are on the plane. Yeah, the moon will speed up and slow down passing. So my first observation was on the 6th. And as you can see there, the moon rise to them. It rises at 56 degrees. It rises at 58 degrees for me, obviously. But obviously it's only available for a short amount of time, because the arrow's pointing in the opposite direction, because it's only available for a short amount of time. Because remember, the moon moon's high on the Tropic of Cancer for us, but for them it's at its furthest point away. Now, if you go across to the meridian passing at 9 o'clock, what you'll see is this is quite an easy one to work out, because on the following night it's at 9:57. So clearly the moon's took 24 hours and 57 minutes to occupy the same spot the following night, which is like I say, I don't need the calculator for that one. So then when we move on to my observation in March, on the 12th of March, as you can see there, look, you've got the straight line, which shows you that the moon will take a straight path, and that's clear by them arrows going in a straight line. So if you go to the meridian passing on the 12th, you'll see it's at 1:25, and on the following night is at 2:12. So for the moon to get to the same spot the exact same night, the time difference is there. Now, I've got the calculator up on the screen, and I put the dates in there. You can see the 12th of the 3rd, 2017 to the 13th of the 3rd, from 1:25 till 2:12.
Well, roughly one takes 2 hours and the other takes 1 hour or less.
Well, no, because I'll show you in a minute. Just,
plus 2 hours or
it looks longer, but it's shorter. It's strange, but I can't. So if you calculate the time, I think I lost my screen now.
So
lost my screen. I've got it back now. So what you'll see then, as the moon goes to the equator, from any location, it doesn't matter where you are, you've got 1 hour and 47 minutes now. So it's actually speeding up on the equator from our perspective in the UK, and it's doing it from the exact same opposite latitude in the south of Argentina on the tip. As you'll see there, look, 1 day and 47 minutes. So it's speeding up from their perspective as well. So we'll go back to the moon calculator, and we'll go back to my observation on the 21st, where the moon slowed down, and we look, it's 8:18 and 9:07. So if you go to the calculator again, put in 8:18 and 9:07. Calculate. As you can see, it hasn't slowed down a lot, but it's slowed down a little bit. It's slowed down to 1 hour 49 minutes. So it's still slowing down from their perspective there. I got from the UK, I actually got 1 hours 52. And I bet if I went to the actual 22nd and did that 9:07 to 9:57, it'd probably be slower again. You just try it. 9:07 to 9:57. 9:57. As you see, it's slowing down again. It's because of the time difference and that. It's as you can see, it's speeding up when it's on the equator and slowing down when it's on the tropics. And it's not just a lack of perspective thing from our observation point. It's clear that it's happening from everywhere on Earth. You know what I mean? So that's where I'm at with that. But what I thought I'd do, because I've captured the moon in August as well, from the Tropic of Capricorn back to Cancer. Instead of doing it just on them observational days, I'm going to do it on every day between as well, so you can actually see the progression, how it speeds up, and then when it actually slows down, and you'll have to see that, and I'll document all that, and I'll present that in the video. But looking at NASA's lunar reconnaissance video, which obviously, according to the heliocentric model, you can look on Wikipedia or Google or whatever you want, and you can see, look about the lunar elliptical orbit, and they'll tell you that the moon speeds up by 6% as it's approaching perigee, and then it'll slow down by 6% as it reaches apogee. So that's according to NASA and mainstream, but by actually timing them culminations in reality, because we know time and date is pretty accurate, and the moon is where it normally is from various readings, whether you use a sextant or use an app, that it's actually where it is. You know what I mean? So it's not like it's the wrong or anything like that. You can rely on that culmination of the moon or that meridian pattern for valid proof that the moon is slowing down and speeding up at certain times of its cycle. Now, we know it doesn't fit the circle model, and looking at this now, it doesn't fit the globe, because it needs to speed up when it's leaving the equator and leaving Tropic of Capricorn and going towards Cancer. That's when you should see the actual speed up. But in reality, it's not doing that. So clearly the ball model's wrong, and the actual circle model, because we know it doesn't speed up when it gets southern declination towards the summer solstice on the south of the equator. So I think we can actually put them two models to bed, really, and hopefully I can put that across in the video and show what I'm trying to explain now, and hopefully that come across all right. Did that make any sense?
Yeah, it's funny how a site's time and date is actually showing the actual stuff, but when you take the official message, it's always 180 degrees.
Yeah, so that's where I'm at, and that's where I'm going with moon race 3. Because, like I say, I tried the last 2 times to prove one thing, but I think we should use it to the advantage to do what we need to be doing, and that is like disproving the actual ball or disproving NASA as well. So we can try and kill 2 birds in 1 stone by actually showing them that, you know what, NASA says one thing, but in reality, this is what's happening, and we can prove that because I've got the observations and we've got the data from time and date. So basically going to use that data to debunk NASA or the actual globe.
You can use prediction so you can actually confirm it in reality.
Yeah, exactly. That's right. And like I say, I caught all the 3 observations. I'll just get the screen up now, and I'll show you this 3 folder.
You got any thoughts, Chris?
Yeah, I think it's great. Yeah, and I think that's the right focus too, is to focus on, just keep on blowing holes in the ball, right, until it pops.
Yeah, so I'm just going to present the screen again, and this is one of my observations, I think, when it was on the equator in August.
What it means to say, Dave, is that you're an ordinary person, just like everyone else, except you started to do research, and really everybody should try and do some of this. What I mean is, 2 years ago, you weren't into any of this. You said you didn't even notice the moon.
Well, I won't even
and now
the moon.
I want to get to the moon. It looks like I can always get a ladder out sometimes and actually climb up the ladder. I can get to that. It's there.
I want to taste the cookie.
I want to eat my cookie.
They're all Cookie Monsters down there.
Like I say, I've learned quite a few tricks on the way as well. Before, when I used to do the moon race experiments, the moon used to be overexposed as it entered the frame. If you look now, I've used the exposure lock on it, so it doesn't overexpose as it enters the frame. So you can, before you get quite a lot of light coming in the edge, and you can't get an accurate reading. So as soon as I see that tip of that moon enter my frame, I can measure it. This time I've got an on-screen clock for Sony Vegas as well. So what I'm going to do, I'm going to do it a little bit different this time. I'm still going to have on screen, but I'm going to have a timer, an individual timer for each one. And then what I'll do, I'll jump to time and date and show you how each observation's matching up with what I'm shooting in reality. It's and like I say, when it's on the equator as well, it's so easy to catch it because it goes in a straight line. Because you start just before it's zenith, and as it passes zenith, it goes in a straight line. But when you do the other observations, because it's coming up slightly, then when it passes zenith, it drops down. It's all over the screen. You know what I mean? Because remember, when you zoomed in like this as well, it's not anybody who's used a zoom camera, you'll know it's not easy to get something as smooth as this going across your screen, and to keep it, it looks like it's going straight, it gets halfway along, then it starts going off the screen. So it's quite a difficult process to try and get the moon to actually travel across your screen in a straight line. Like I say, I've done it quite a lot of times now, and it's been quite a lot of trial and error as well. You know what I mean? I've been doing a lot of swearing outside on the back garden and all sorts, and getting quite frustrated because it can be quite frustrating at times. And it was frustrating when I did it in the daytime, actually, because there was just a little sliver of the moon visible, and I was aiming my camera up at 50 degrees. Yeah, and you couldn't focus on it. You had to do manual focus, and obviously that AEL lock, that exposure lock. There was clouds coming past, and the sun was coming round the side of the house, or the light was jumping in and all sorts. But as you can see, it's pretty level in the screen, and that travels from basically one end of the screen to the next. This time I'll use a different time. What I'll do, I'll start it when it actually first enters the frame until it completely leaves the frame. And that'll give me an even longer time scale as before to make my observations more accurate as well. Because on the last video, what I did, I stopped it as the moon itself touched that side. This time I can let the moon go completely off the screen like that.
Don't you need a full moon for that?
Say again, serious?
Don't you need in all cases then a full moon?
Well, no, because what you can do, I use one side of the moon to get level on one observation, and I use the other side of the moon from the other phase to get level on the other, and then I bring them to the same position. It is quite tricky to get it like that, and I made a mistake on my original moon race video because I used the actual tips of the actual crescent moon as a measuring point when I needed to use the actual full moon itself. But it does take a little bit to get it actually right. But you can actually see when it it goes on screen. You know what I mean? It's no advantage point to start it. They're all starting in the relative same position, and it's just a matter of when they get on frame. What I do, because you can overlay them on Sony Vegas, I just overlay it, and you can see. I'll just let this run here, and you can just see how much of a job it is to try and get the moon lined up to go off your screen. It's rock hard because you have to do it as it's off the screen, and you don't know where it's going to come on. You know what I mean? Sometimes it's off the screen, it comes on, and it's not even on screen. So, because I'm zoomed in at times 50 there as well, it's not like it's quite far away. It's zoomed in a lot. So any small movement, it will. But you can see it's a nightmare.
It's microscopic work.
Like I said, I'm only doing very, very small little moves now. It's the tiniest little moves on the tripod, and you can see the moon is jumping everywhere. So gone. Then it appears again. Look, then it disappears off the screen for about 10 minutes. I don't know where it's going to come on. So, but that's where I'm at with that, and hopefully I can start banging the video together. I wanted to start it there when I was on holiday last week, but I never got around to doing it actually because I was a bit busy. But that's where I'm at with that, and I really enjoyed that, and hopefully I can put that across, present that in my next moon race video, and this time we'll go after the globe and put the globe to bed.
That's for me already a year in the garbage can.
It's a lot of work, a lot of research, a lot of planning, a lot of filming, a lot of editing. I do understand that, Dave. But, if it wasn't for people like you and people like Ceres and people like Chris, we wouldn't be here.
No, exactly. And you know what? Like I've said before, if I can just find one little piece of the puzzle, you know what I mean? I'll be happy. You know what I mean? We're all contributing. I'm not just doing the moon race experiments. I've got all sorts going on in the background. You know what I mean? I'm doing Facebook posts. I'm doing sun observations now. You know what I mean? It's not just one thing. So I'm squeezing everything in. Plus I've got a full-time job. I work alternating shifts. I've got a 3-year-old son. I think I need to go to the Enoch calendar, get an extra month in the year.
A few more hours in the day,
Yeah, never enough time, hey, Dave?
No, like I say, it means sometimes it means sacrificing a whole night's sleep to try and get something finished. Or, like I say, one of them observations was shot at 3:46 in the morning. Do you know what I mean? I needed to get the moon at zenith on the equator, and so that meant getting up at 3:30 in the morning, getting set up and shooting it for 3:46, which I did exactly perfect time like. Because all them observations I make, apart from the first moon race, was at zenith, because I think when it's at its closest point to me, I'd get a more accurate reading. Because, like I'm sure Stan mentioned before, that the moon does rise faster. So if you imagine if I angle my camera to catch the moon on rise, it would appear to move across the screen faster, and I would get probably a different reading. So that's why I always do the readings at observations at zenith.
So how much time is it? How much before you reckon your video will be ready, Dave?
It won't be for quite a while. I'd said maybe a month or two even. I only get like a half an hour at a time to do it, you know what I mean? I've just got to plan it all first, get it all together, and then start building it up. So it's not going to be like I say, I can't put these videos together in like a few days. I only get a small amount of time, maybe late at night one night. So it's a long frustrating process, but you know what I mean, it's one that has to be done, and it's the only way I can do it. I can't just stop what I'm doing and not go to work and not look after my son and everything else what needs to be done. You know what I mean? I've just got to squeeze it in when I can.
You do really well, Dave. And like when I met Ceres to start with, basically it was a bit like, oh, you're going to bed at 2:00 in the morning. You're going to bed at 3:00 in the morning, 4, 5, 6. And sometimes Ceres doesn't go to bed for 2 days. It's this is what happens when you become a flat earther. And I'm sure it's the same for Chris, isn't it, Chris? Before you met us, you're probably going to bed at normal times, or maybe 2, 3 in the morning. Now, still up when I'm getting up.
Yeah, flat earthers don't have much more than 4.5 hours, 5 hours sleep. Normally I have like, if I'm on afternoons, I might get 6, 7 hours sleep, but when I'm on earlies, I'll only get 3.5, 4, 5 hours sleep maximum. So
yeah, that sounds like me. How many hours sleep do you get in a go, Chris?
Oh, I'm more of a cat napper these days, I think. Yeah. couple hours here, 3 hours
Same
there,
thing.
whatever. Yeah.
Yeah.
Series?
Same thing.
I know Series does actually get some sleep when he goes to sleep, don't you, Series?
Yeah, sometimes 3 hours, sometimes 6 hours, sometimes 12 hours. Depends on what happened before. Eh?
Problem is when you have a short amount of sleep, when you do have a long sleep, I always feel dead groggy and dead like, you know what I mean, dead tired like, or a headache or something like that. So
Yeah.
I'm
Sleep too
happy.
long, yeah.
I'm happy to have like 6-7 hours sleep.
Yeah, usually 6.
Yeah, you're better off just to follow your natural cycle and sleep when you're tired and get up when you're not, and then don't try to force it and sleep too long. You'll actually wake up more tired when you went to bed.
Yeah, it's horrible when you wake up like that. I've actually had 12 hours sleep, and then like an hour later I've been sat down and I've been falling asleep again.
I can feel it when I only took 3 hours, but I'm not really not too tired actually.
Dave, you were talking about the sun. You're looking at doing some work on the sun now too, eh? I got a website there you might find handy to save you some work, maybe.
Cool. Yeah, like I say, I thought running up to the equinox, I'll do that experiment and try and get a few more on board, like Anderson and Jose and Karen B. So I just thought it was quite a simple experiment, and it'd be interesting to see what I'm going to put actually a post on Facebook, because I've actually done the observations, and I've shot the sun over a day. I've only took 2 readings. I took one in the morning and one just before sunset. So there's about 11 hours between them. But like I said, there's about between 80 and 90 degree rotation of the actual sunspot. I know what ballers will say, yeah, it's due to the Earth's tilt, blah, 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 blah. Yeah, but that's why I thought I'll put the post out and see what the feedback is, and then I'll do it again on the equinox and see what the feedback is, then say, well, hold on a minute, the Earth planes are aligned with the center of the sun. You know what I mean? There should be no rotation. It should just literally, we should just pass the sun on that. Well, the Earth should just rotate. You know what I mean? In a perfect straight line, basically. If you know what I mean. So that's what I'm going to do with that anyway.
Yeah, you see, equator is kind of the middle point of the poles, and everything towards one of the poles is bending towards the poles. The sooner it gets out of your zenith position, comes out, goes to.
Yeah, interestingly, on the equinox, I'm sure you've heard this before, but it doesn't matter where you are on Earth, everybody gets 12 hours day and 12 hours night on that day. You know what I mean? Even if you go far north or far south, we'll still get exactly 12 hours night, 12 hours day, which is...
This is right, it seems.
Yeah, which on a ball...
I'm sharing some pictures there, Dave, that might save you some time. I'll just mention this photographer there, because you could just look at some of his work and then draw conclusions, because he's got some pretty good descriptions of where he was, what time it was when he took the pictures and stuff. But what he's doing is, here's one picture. He's actually taking what he's calling like burn through photography. So he uses like a silver type of film, a special type of film that has silver coating on it. And then when the sun, he puts it in the long exposure mode. So he just opens up the aperture and lets the sun burn the image into the film. So he's got all these images. His name's Chris McCaw. He's got his own website if you find his website. But he's got all these images where the sun is burning the arc. Like some of them where he patches together, you can actually see the arc. Right. So if you could tell where he's taking the picture from, you can triangulate basically the arch that the sun is actually traveling in on a daily basis.
Yeah, well, that was cool. That.
There's all kinds of Chris
is he from Australia?
Yeah, I think he's a photographer. Some of them he's taken. He's worked up in Alaska.
All right.
Yeah, the sun will actually. It's so hot when it hits the film, it actually bleeds through and burns so it's actually burning a hole in the film, right? And then it bleeds through. It's melting the film. Yeah. But it's interesting because you can see how it actually, in some cases, it burns a hole in the background. You see a negative image of the trees that it burnt through the cloud of the air, right? And then, But I thought it might save you some time, because you might be able to say, okay, well, if he was taking the picture from this point and this is the arch that it burnt in the sky, right? You could kind of say to time and date, if I'm here and looking obviously where the sun would rise and set, you could figure out, right, from time and date, if that's the arch that it should travel relative to that perspective, right? You can see it, maybe work out the path that it's actually doing, because you would think if you're on a spinning ball, it should be a straight line, like you said, right? If you're standing anywhere in the sun, in the spinning ball, it should go a straight line across the horizon and rise, set. That's it. You're done, right?
Yeah, it should be like that. You know what I mean? It should always be that angle, shouldn't it? If you think about it, if you're looking out from a ball, it should always be that straight line, doesn't it? But obviously, we see the sun, it'll curve around us here, then it'll be traveling in a straight line in a few weeks, and then it'll start arching away from us.
It does a bit of both, yeah. He's got some pictures there where he stages them together. You can actually see the sine wave, right?
Yeah.
That's in a 24-hour period. You can see the rise and set and the sine wave. Yeah. So it's going up and down, up and down. Yeah. In a magnetic field, I mean, I see that. I just think instant magnetic field, right? Magnetic torus. Right?
Yeah.
Yeah.
I thought also, like we did the moon race experiment. I thought with it coming up to the equinox, if I catch the sun with my filter on and do the same kind of experiment, then I know it's going to be a long way, but till the winter solstice. But I thought maybe I might try it with the sun. You know what I mean? Just keep it saved in a folder on the computer. Take the readings and just try and do like a sun race video. See if I'm getting the same results with the sun as we're getting with the moon.
Yeah, that'd be really cool. Try that.
Yeah, that's what I thought. Like, so you've got a few days to play with it when it's on the equinox. You know what I mean? Like with the moon, you've literally got. I give myself 3 days to like catch it. When it's on and around the equator or on and around the tropics. I always give myself a 3-day window because the one where it actually is got the southern declination, one where it's at its furthest point, and then the next one as it starts its northern path again. So I always give myself 3 days around that. So with the sun, you've probably got a week or two around each recording. You know what I mean? When it's on the equinox, it's on there for a few days, isn't it? Like till it starts changing. Like, so I thought maybe I'll do like a sun race, and then next summer, I know it seems a long time. Next summer, maybe I can do a sun race video and see if we get the same results. Only thing is though, that time and day only to show the time of solar noon. So whether that's same or not, I'm not sure. I haven't looked into that. Well, what's your thoughts on that, Chris? Is there showing the solar noon just same as showing the culmination of the moon?
Yeah, I think it's pretty much just doing the same thing.
Same thing, yeah.
Yeah, it's interesting too that you talk about that 5-degree inclination, right, and how that so coincidentally, correlates with the 23.44 degree tilt and a 5-degree inclination, right? So if you do the sine, cosine, tangent on that and get the hypotenuse right and calculate from the distance, you'll end up seeing that I think we had mentioned this before, that the distance right on the other side is actually the exact same distance of the supposed ball's diameter, right? So when you do that, you end up with 0, right? Because you got the inclination equals the altitude, which equals the diameter of the object, and it just all three cancel out to nothing, right? So then you can draw a circle. Then you can draw a circle and make it work, right? Yeah. It's very, very strange mathematics going on there.
Yeah, and like I say, why does the Earth rotate and the Moon doesn't rotate? You know what I mean? You can't have both, can you? You can't have one like tidal locked and the other one spinning in space, can you? On an axis. You know what I mean? It should be the same for both of them. They should both be either locked, like the Earth locked to the Sun and the Moon locked to the Earth, or the Moon should be spinning around like the Earth does.
Well, if gravity were real, and you had gravity, yeah.
Yeah, do you know what I mean, though? If you think about it.
Yeah, no, you're right. In free space, if gravity were real and you had two objects of different mass, but one was rotating around one at a different rate than the other one was spinning, you should have drag, and that would cause the other one to rotate counter to the one that's spinning, like two gears in a motor, right?
Yep.
The big one spins one way, and the smaller one would spin faster in the other direction, just because of the gravitational drag. If they had a center of axis, both pointing in the same direction, right? So it makes absolutely no sense to me at all, right?
Yeah, and also, as you know, Tesla proved that the Moon doesn't have any actual rotation anyway, does it? You know what I mean? It's like a spoke on a bike wheel.
Yeah. Yeah, in free space, I mean that's the way it would in theory work, right? In free space.
Yeah, I was thinking like heliocentric side of it, kind of thing. But it doesn't make no sense.
What I start thinking about that type of stuff in the instant. The image that goes through my mind is a clown on stage, dancing on a ball, right? Or a logger going down a river, running on logs, right? In order to stay upright, the log has to spin, and the faster it spins, the faster you got to run. Right? The same thing in free space. That's what happens to spinning objects. Right? One affects the other. You can't disconnect them. Yeah, so you're right. It makes no sense at all to be one locked and not the other. Right? Unless there's a string attached to some miraculous string that's attached to the center of the other. But then it wouldn't spin around at a different rate. You wouldn't get any cycle of 29.3 days. Right?
Yes, somebody sent me a link to a video for the Cavendish experiment where it's been recreated, and the video come on. It was like a 1990s video, and you had basically two weights, and what they did, they brought these two big lead balls to either side of it, and then the thing is though, the camera camera actually changed, and you had like these silver balls on this like pole, and then you went to these like gold balls on a pole. They completely changed the picture, and then obviously you see the attraction of the larger object attracting the smaller objects, which to me, I've heard quite a few people who actually tried that experiment, and it's always failed.
Well, if you notice in that video too, they had some wires connected to that video, so they were injecting a static charge to cause the attraction, which is probably, Cavendish's balls on beams were made of lead, right? So they're basically just pendulums, and we know that a gyroscope will be attracted to north because it's a spinning type of thing. So it's the magnetic field that's causing these changes. Like Foucault's pendulum, it's the magnetic field that's moving. When the magnetic field moves, the pendulum moves, and we see the same thing, the alias effect during eclipses. That's why it's the alias effect, right? You have a pendulum spinning or a pendulum swinging during an eclipse. Well, it'll change the path of the pendulum as the eclipse goes overhead because it's such a huge magnetic anomaly, right? And that's why you feel cold. Like I said before, like when it passes over our heads, you feel cold because it's a negative dielectric charge, right? Which changes the path of the pendulum.
Yeah.
Right. So,
yeah. I wonder if anybody did that experiment when the eclipse happened and the pendulum actually changed direction. Because I know they were.
I don't know. There's a few people talking about it, but I don't think any of the guys that I was chatting with, taking pictures and stuff, I don't think they actually had a setup to do it. But
yeah, I think everybody's like we're just too busy trying to actually capture the eclipse, weren't they?
Yeah, it would be something interesting to do. I mean, if you had the ability to do it somewhere like in a gymnasium or a tower of some kind, even relative to the moon, right? Just attach a rather large aluminum ball, make it out of aluminum, some kind of a dielectric material, and get it swinging. And then time it with the moon and see if when the moon passes, if it changes the direction of the swinging pendulum, it should actually put some torque on it. You should see the pendulum kind of follow the counter direction of the moon as it goes over. It should go around in a circle, right? In theory.
Have you tried the Cavendish experiment before, Chris? Or
no. Actually, something better. Now that I'm thinking about it, something you could do that's even cheaper, right? Take a pendulum somewhere in a barn, wherever, it doesn't matter, somewhere where there's no wind. Hang it from a chain, but put a 5-gallon bucket, fill it full of salt water, and then swing it as the moon passes over and see if it moves. If it's salt water, it should move because the oceans move with the moon, right? It'd be fun to try that.
Yeah, that's what I tried in my my moon job experiment. when I put a glass of salt water in the window as a full moon come past to see if it had any reaction, and it didn't.
Probably not enough volume, right? Or free space.
It was a tongue in the cheek video, just to stick your finger up at gravity kind of thing.
Yeah, there would be enough volume, not enough charge. Yeah, the dielectric glass would interfere, but a free spinning pendulum with salt water in a bucket might work.
Yeah, that'd be interesting. Yeah. Right, I'm gonna have to shoot off then, guys, because I've been up since 4:30 this morning.
No, Dave, another 6 hours to go yet. Got to stay on Hangout for a lot longer yet. Only joking.
Yeah, no.
You take care, Dave. I want
to go mainstream and watch Formula 1 Grand Prix.
You're swapping us. Anyway,
that's the only mainstream thing I do, watch Formula 1, and I've watched that since I was a child, and I'm not stopping. I don't care what anybody says. I'm not stopping watching Formula 1. So.
Well, we've been going for nearly 3 hours now. Do you think it's time that we sort of finish the hangout?
Yeah.
Hangout, and a lot of time talking this week. Shall we go at the same time then, guys?
Yes, definitely.
Please.
I'm fine with it.
Chris?
Yeah, sounds good.
Yeah.
I was just trying something here too. Let me share the screen here. Just trying something here.
You can go, my darling.
Dave might like this real. I'll do it real quick for you.
Oh, okay then.
So this is to scale. Let me get this down a little way here. All right. So what I got here is a rather large stick sticking in the center of a ball, and it's to scale, and the sun is way where it's supposed to be. It's got the globe with the atmosphere and everything else. And what I'm going to do is I'm going to grab the Earth object and the giant cylinder that's actually miles high. The sun's 90 degrees parallel to the ball, so this is dead center on the equator like that video was trying to show. I'm going to rotate them both on the z-axis. You'll see that if it's at that distance, there is no shadow, right? Very little declination in the shadow, right? Unless you get way over, right? And then spin the ball the other way. Right? it doesn't work. So whoever made that video, good luck to him trying to get that to work. But let me see. I'll show you here the other way. Let me put that back to the front view. View from the front. Rotate it. Grab the cylinder and the earth. Rotate it on the Z. Let me get the cylinder here too. Cylinder and the earth. Rotate on the Z. Now here's the proof of their video there. I'm going to grab the sun instead at its distance. And I'm going to rotate it on the Z. So if the sun goes around the object, you can get a shadow, right? But that would be counter to the heliocentric model now, wouldn't it? So rotate on the X, right? That's the only way it works is if the actual sun is moving around the Earth. So it would work on a geocentric model, but not on a globe model. That video there that's trying to debunk the theory, right?
Yeah, that's spot on. Yeah, makes sense, doesn't it?
Yeah, because the distance of parallax, 93 million miles is too far. Like you can see, I'll do it again for you, so you can see. You take the Earth and the cylinder, which I showed you is miles high, right? I got it sticking out there 1,000 miles. Take the Earth and the cylinder both, rotate them on the Z-axis. There's no shadow because the distance to the sun, there's not enough parallax, right? Unless you get way off to the side, right? Right? Because the angle of the light doesn't change because it's coming in a straight line regardless. So we wouldn't actually, if at that distance, that kind of shows us that we wouldn't have shadows on Earth very much if it was that far away, unless the light itself is moving. So if I rotate the sun,
something like the moon edge, where you only see the craters at the moon edge, right. The light edge.
Yeah, if you rotate the sun around in a circle or on the Z-axis, right, then you can see. Then you would get shadows, but it's only if the light angle is actually changing. Interesting, eh?
Yeah, that's cool. I wish I know to you. What programs is that Blender?
Yeah, I'm just using Blender for this. Yeah, and I got the moon in there too, right? Just right. So I can do experiments based on, I can basically say, well, there's my big stick on the Earth, right? And if I rotate the sun around the Z-axis, which is way out there, it's too far for you'd even see, but then you can see the shifts, right? There's your phasing and your moon cycles in theory, right? But you'll notice in the model of when I do it to scale, all the pictures from space supposedly, right? For the longest time, they didn't have any atmosphere, right? And now they're starting to show atmosphere, right?
Yeah, I've noticed that.
Yeah, and you can see now that if you do it properly with an atmosphere, you would get more of a gradual shadow effect, right? Twilight, you would see that as twilight, etc. But yeah. And I can actually remember that one where the moon passes in front of the Earth and they got the scale wrong.
Yeah.
Well, that's what they did is they did it in CGI and then they just moved the moon, right? But they forgot to zoom out to where the satellite actually was and put the satellite, the camera on the moon itself, right? Because it would have changed everything. Right?
That was shocking. That really was shocking.
Yeah, they forgot to put the camera in the Well, the reason they do that, I'll tell you why they had to do it that way. Because if you're using this type of software in Blender and it actually replicates reality, right? You can't be at the distance of the supposed satellite where it's supposed to be near the sun, looking back at the Earth, right? Because that camera,
a million miles away. I heard.
Yeah, it's only a 30-inch telescope, right? So it can't even see that far, right? I tried it, and this thing, I'd have to have a telescope, near a half a mile long between the two lenses in order to get enough magnification to even see the Earth from that distance, right? Because you can't do it. Because as you know, you're into photography and telescope work, right? Unless you can actually zoom and get enough zoom to actually bring that into focus at 10 miles, right? Then you can't see it.
Yeah, and then it wouldn't be in the frame for very long either.
No, it wouldn't be. Yeah, it'd be like a bullet going across the screen. Well, there goes the Earth. See you later. Yeah, exactly. Yeah, that's funny.
Yeah, cool. Right then, guys, I'm going to shoot because it's like midnight. I've been up since 4:30 this morning and I'm tired.
Have a good day.
Thank you for coming on and explaining all that.
Yeah, enjoyed it.
So you'll be back.
See you later, Dave.
Just asking,
Thanks
are you
again.
going to Cardiff meet on Sunday?
I'm not going to any other meets now because I've got to pay my flight tomorrow for my flight to America. So I'm basically in full save mode. Yeah, I've literally got to really save my money, like I say, because these flights are going to probably cost me £1,000. So it's not going to be
Explain that Dave's going to the US conference in November.
Yeah, like I say, it's not a cheap event. You know what I mean? The tickets were like £140 each or something like that. The flights are £491 each. The hotel's £600. It's not a cheap deal. And then obviously all your travelling, because I'm going on the train. The train's going to be 60 quid, isn't it? 70 quid to Birmingham. So it's just cost. You know what I mean? This is like trying to separate myself from other flat Earth groups who funding their their pages and what have you through Flat Earth Research, where, you know what I mean, I'm digging in my own pocket and paying for this stuff myself. I'm not asking anybody to give me any penny or whatsoever. I don't monetize my channels. I don't ever ask anybody for money. You know what I mean? I buy my own books. I buy my own camera equipment. I don't have a GoFundMe account so I can buy a telescope or anything like that. I do it all out of my own pocket. So Flat Earth is not cheap, put it that way.
No.
And I'm going to have to get off because I'm falling asleep.
Yeah, I think we're all a bit tired on Friday night. I asked Artist, but I don't know where he's gone. We're back on Sunday, Pyramid Talk again with Angel and Artist on the panel. So that's a good night. And I'll just explain it because I make little videos. But anyway, next week on Tuesday, we have Patricia Steer and Mark Sargent. And then on Thursday night, it will be a later hangout because Santos doesn't, he comes on at 8 o'clock in the morning, Friday morning, even though we're talking to him on Thursday night. We've got Santos Bonacci again. Looking forward to all of next week, Sunday, and brilliant hangout again. Chris, are you going to come back and say goodbye? Patricia?
Yeah.
Patricia, come back. A hug. Yay. Panel, and for everybody that watches this and in the chat room, thank you so much. We'll be back on Sunday, 9 o'clock, and thanks very much to everybody. Chris, thank you very much. Dave, thank you very much. Series, thank you very much. Tricia, thank you very much.
Right, thanks everybody.
Love you all.
Good evening. Have a good weekend. Enjoy the bank holiday. Bye-bye.
UK.
Bye.
Cheers.